Hello everyone, welcome to Rubber Industry NewsHour. We are on the episode number 12 on 4th April. This is a weekly program for rubber industry. Welcome you all. Namaste, Sawadee Krap. As you know, this is a techno-based initiative. Before I go into today's episode, let me give you a brief overview about what is the rubber industry NewsHour means, what kind of things are there, what we include in it. Let's have a quick look at the video of the rubber industry NewsHour. Okay, that's about the rubber industry NewsHour. See, we may not cover all the things in each episode. We take one or two sessions and we include in that each episode. But it covers you everything about rubber industry. As you know, this rubber industry's NewsHour is managed and owned by Technobase. I think some of you know about it, Technobase, very well. Some of you may know a little bit, or some of you don't know anything about it. So for the benefit of everyone to understand more about Technobase, let me show you a short presentation on the Technobase and what kind of services we offer for the rubber industries. That's about the TechnoBiz. I'm hoping that you get a better picture of what is TechnoBiz and what kind of services we offer for the rubber industries. As you know, you can always reach to me if you need more information on the TechnoBiz. Okay, let's get to today's session on the episode number 12, Rubber Industry News Hour. Let me give you what are the highlights of this session today. First, we will have the natural rubber market review by Mr. John Jacob. We'll be discussing about the natural rubber market developments. Then we have a special panel discussion focusing on the present and future trends of textile reinforcement in tire and rubber industry. We have three experts, Dr. Barun Samoi and Mr. Narapati Dhar and Mr. Veeresh Sharma. So they will be discussing about what are the changes, developments related to the textile reinforcement. Then we have a commercial part, which is we have rubber industry business profile and also rubber industry buyer guide. It is basically an advertising session. So these are the main, highlights of today's program. I'd like to request to all of you, if you find this event, Rubber Industry News Hour, useful, I do encourage, suggest to share this information to your colleagues or industry friends and invite them to come join on Monday. If not, they can always view it on our YouTube channel. As we are trying to cover very useful subject relevant to the industry. As you know, TechnoBiz is a specialist in the rubber industry. So I believe that your friends and your colleague will benefit from this program on every week. All these rubber industry news over all the past episodes you can find on our TechnoBiz channel on YouTube. So feel free to check it out when you find a time. Okay, let's get to the first session today, rubber industry market review. In this rubber industry market review, as mentioned to you, we cover the natural rubber market developments. And we have Mr. John Jacob. He is a global rubber industry analyst with more than 30 years experience in analyzing rubber markets, forecasting industry trends, and formulating long-term policies and development plans for natural rubber sector. He served the Association of Natural Rubber Producing Countries, ANRPC, in Kuala Lumpur as its senior economist for 11 years. Before that, he worked for the Rubber Board of India for 23 years in various positions. So let's welcome Mr. John Jacob to give a overview on the natural rubber market.
Hi all, welcome to the natural rubber market review. So before we review the performance of natural rubber prices in the futures and physical markets, let us have an overview of the economic and political economic and geopolitical background setting during the previous week. When we look into the market sentiment during last week, Russia-Ukraine war and the economic sanctions announced by the West allies on Russia continued to dominate market sentiments during the last week. We have seen various rounds of peace talk between the two countries, but they could not translate into a ceasefire. However, there are some easing of the concern. Means compared to a week before, situation is it is slightly the concern. The concern is a little bit eased as of now. Then coming to the crude oil market, which is another important market, especially when we look into the commodities. Crude oil has a major weightage in the commodity basket. So we have seen crude oil market falling from the peaks. For example, Brent crude oil scaled up to around $135 over the past few weeks, and today it came down to the level of 103. That means the Brent crude oil fell by nearly $35 over the past few weeks. The fall in oil prices is because the supply concerns is following the decision by the US to release strategic oil reserve to cool the oil prices. There is another factor which also contributed to easing the supply concern. UAE and the Iran-aligned Houthi group reached an agreement, means some kind of a truce to halt military operations on the Saudi-Yemen border. So this new development has also contributed in easing the concerns about the potential supply issues. So now maybe we will have the question: oil price falling down, that means will it translate into a fall in NR prices? My answer is no. Falling oil is a relief to manufacturing activities world over as of now, because manufacturing sector world over is reeling under cost escalation due to high fuel prices. More than that, inflation pressure is very high as of now because of the fuel prices, largely because of the fuel prices. So the falling oil prices will be a relief to manufacturing activities world over, as well as it can help in taming the global inflation worries. So indirectly, this can help the demand outlook for natural rubber. So this is meant so falling oil at the present moment can be a positive factor to the natural rubber market. And we have to take into consider that when oil prices went up, soared to $135 from below 90, it reached $135 over the past few weeks. It could not exert positive sentiment in the market because market took the high oil price as a negative factor because of its negative implications on the manufacturing sector as well as on the global inflation or on the global economic recovery momentum. So that negative factor is now easing because of the falling oil prices. Another important factor which can have implications on the rubber prices, which has actually influenced rubber prices over the past the last week, is the currency factor. To be more specific, Japanese yen fell to a 6-year low. Japanese yen fell to a 6-year low against the dollar. The weak yen makes Osaka rubber futures, means rubber futures traded on the Osaka Osaka exchange, more attractive. It becomes cheaper and more attractive to speculative investors. That means a weak yen means more buyers will be attracted to rubber futures traded on the Osaka futures exchange, and that can help rubber futures. Today, RSS3 futures traded on the Osaka exchange settled 8 yen per kilogram higher compared to the previous day, largely driven by the yen's weakness. Not only yen's weakness, another factor is also contributing to the RSS3 futures traded on the Osaka exchange. Physical market of RSS in Thailand is tight as of now. This is due to the seasonal short supply. RSS has a niche global market. Processing of raw rubber into RSS is highly labor intensive compared to processing into capillum, compared to selling in the form of capillum or fresh latex. Processing into RSS is labor intensive. As a result, seasonal shortage is felt more severely in the case of RSS than in the case of capillum or TSR. So market arrivals of RSS have reportedly dropped in Thailand in the past few weeks because of the seasonal short supply. That means that market arrival is more severely felt in the case of RSS than capillum. So coming to India, RSS4 market in India, we have one important point to be discussed now. Summer rains, Kerala, in around 80% of the natural rubber produced in India is coming from the state of Kerala, where summer rains have reached, means almost entire parts of Kerala have received summer rains. So farmers are expected, or maybe the regions which have not received will be getting rain these days. So that means farmers are expected to resume tapping in the next few weeks after the wintering off season. So supply season is going to start uh, slowly picking up. We can pick up in the next few weeks, the next 2 weeks in India. So RSS4 price can have yeah, some kind of a negative influence due to improving supply. Then another factor which has affected rubber prices in the past week was China's manufacturing sector contributed, means China's manufacturing sector contracted, means manufacturing activities slow, it came down during March. So the manufacturing purchase managers index, or PMI, fell to 49.5 in March. 49.5 means less than 50 means manufacturing sector is contracting. So it came down. 50.0 means a manufacturing sector contracted in March. And we have to consider that China's manufacturing contraction and resultant slumping demand, it can have negative implications on the manufacturing activities across Asia. So China's slowing manufacturing or China's slumping demand can have negative implications on manufacturing across Asia, because many of the Asian countries are actually suppliers of the China's manufacturing sector. So that means we can expect some kind of a slowdown in the case of other Asian countries as well. As the demand outlook for natural rubber would be weighed down due to the same reason. So this is a negative factor, not only for China as well as for other Asian countries. Then we have seen imposition of 9-day lockdown, complete lockdown in the Shanghai city. It was imposed on last Sunday, that is 27th of March. And this has badly hit the market sentiments. This has been reflected in the rubber futures traded on the Shanghai Futures Exchange more severely. That means we have seen Shanghai market could not keep pace with the SICOM or Osaka Futures Exchange or other Asian physical market, because Shanghai, the lockdown in the Shanghai is having more reflection in the Shanghai Futures Exchange rather than in the other exchanges. Then another important factor was the US inflation set a 40-year high. US inflation means it's 40-year high means inflation actually heated up substantially. And inflation gauge that is monitored by the Federal Reserve jumped to 6.54% in February compared with a year ago. 6.4% inflation means it's a 40-year high. Then similarly, in the Eurozone region also, we have seen inflation surging to 7.5% in March. That is another record, setting another record. Then coming to the US jobs creation data, or non-farm payroll, expanded by 431,000 in March. In fact, 431,000 expansion of the job creation it was lower than market expectation. But still, market took this number as an encouraging one, because market was, in fact, actually this number is despite having unfavorable labor market condition and soaring inflation, as well as worries about the looming recession. So this number market took in a positive sense, even though it is lower than the expectation. Market took it in a positive sense. And last week also has seen US dollar strengthening by resuming its rally. A stronger dollar makes speculative trading less attractive, and hence it discourages investors from investing in various portfolios, including rubber futures. Then coming to physical markets, natural rubber supply remains low due to the annual wintering of rubber trees, remains low. And however, a slowing demand outlook partly took away these positive effects. So we have on one side the physical market supply is low due to the seasonal factor, but on the other side demand has slowed down due to various reasons. So various reasons I will elaborate now. Rubber-based manufacturing activities have been impacted globally due to the fallout of the Ukraine war and the COVID lockdown in Shanghai and other parts of China. Manufacturing contraction in China we have seen. Slowing manufacturing activities in other Asia because of the China's slumping demands. So Japan, South Korea, Taiwan, Vietnam, and Malaysia have reported indicated slowing manufacturing activities during March. And also manufacturing activities have been impacted by high raw material prices and overheated inflation. That means on one side we have supply low due to seasonal factor, but on the other side, or in other words, the positive effect of the low supply has been nullified, partly or fully nullified by the downward revision or downward outlook, demand outlook. And so these were the various issues, various factors which have impacted the influence of rubber market during the last week. And in fact, this is a situation as of now. With this information in background, let us look into the prices, performance of the natural rubber prices in the futures and physical markets in the last last week. So we have 6 charts here. Chart number one is reviewing the rubber futures. So in fact, the graph is showing the daily settlement prices of rubber futures traded on the Shanghai Futures Exchange from mid-March onwards. Means the last 3 weeks are shown here. And when we focus on the last week, means a week ended on 1st of April. Last 5 means 5 days of the week ended on 1st April. But that means I request you to focus on the last part. So the last week, Shanghai rubber futures average 0.6% higher compared to a week before. So in spite of all the negative factors we have mentioned before, in spite of the Shanghai lockdown, in spite of the manufacturing activities contraction, and also Ukraine war, despite all these negative factors, Shanghai market was up by 0.6%. It averaged 13,510 yuan. So this is up largely because of the favorable fundamental, means supply is low. That is one reason. And also, even though demand outlook has been weighed down by the negative factors, the supply concern is actually supporting the prices from falling down, and it is marginally up. Now let us see chart number 2, which is showing the SICO markets, Singapore Commodity Exchange, how the TSR20 futures traded on the SICO market performed during last week. So this graph also is with reference to the period mid-March, 14 March onwards until 1st of April. When we focus on the last 1 week, that means a week ended on 1st April, SICO TSR20 average 1.6% higher. The average price during last week was $174 per 100 kilogram. So compared to Shanghai market, SICO performed better. As I mentioned before, Shanghai market had an additional negative factor because of the lockdown in the Shanghai, complete lockdown in the Shanghai. So that why Shanghai market would gain only 0.6%, whereas SICO market gained 1.6%, means average 1.6% higher compared to a week before. Now let us look into the RSS3 futures traded on the Osaka Exchange. We'll go to chart number 3. In the Osaka exchange, RSS3 futures averaged 1.2% higher during last week compared to a week before. The prices averaged at a 256.9 yen per kilogram. In fact, the graph is from mid-March onwards. So I have the average shown here is with reference to the last week only. So these are the price performance in the three futures exchanges, which are the key three important futures exchanges in the Asian market. So all the three exchanges prices gained. In fact, in the case of Saicom and RSS3 Osaka, the gain was higher compared to the Shanghai markets. Now let us go into physical markets. Around 70% of the global trade in natural rubber is in the form of block rubber, which are traded in the various forms like STR20, SMR20. So different countries are selling in different form. Generally, we call them TSR20. So this graph shows the prices of STR20 with reference to FOB Bangkok, which is given in the blue line, and also we have SMR20 Kuala Lumpur with reference to SMR20 FOB Kuala Lumpur, which is shown in the orange line. So both the prices were moving almost in the actually tracking in a similar way. Means they were actually prices were moving together almost during the period from mid-March onwards. So during the last week, I mean the week ended 1st of April, at the Bangkok market, prices averaged $174, which is 1.0% higher compared to a week before. In Kuala Lumpur market also almost same, nearly $174, which is 0.5% higher compared to a week before. What is interesting is Psycho futures market, Bangkok physical market, and Kuala Lumpur physical market. In all the three markets, prices were $174. When we round the figure, $174 means a few futures and physical market moved average at the same level. This is very important. This is very interesting as well as very important. I think good to see that futures are actually reflecting the sentiment, the development in the physical market. We'll go to the RSS market. We have chart number 5, RSS markets. RSS market, we have two markets. One is RSS3 Bangkok, which is actually FOB market, RSS3 FOB market, which is given in the blue line. And also we have RSS4 Kottayam local market, which is not FOB, not including taxes or other charges. So in the week ended 1st of April, Bangkok RSS market averaged $230 per 100 kilogram, which is 3.6% higher compared to a week before. And the Kottayam market also average is almost same, $230 per 100 kilogram. But compared to the previous week, the increase is only 1.8%. What is interesting is both Bangkok market and the Kottayam market averaged during last week at the same level, around $230 per 100 kilogram. And now we will go to the latex markets. Latex market, which is chart number 6. We have two markets. One is Kuala Lumpur market. In Kuala Lumpur market, latex averaged $162 per 100 kilogram, which is a 1.2% higher compared to a week before. And when we look into the Bangkok market, latex averaged nearly $159 per 100 kilogram, which is 2.0% higher compared to a week before. And also we have seen that actually the graph is showing from mid-March onwards. The prices actually at the mid-March, the two markets were divergent, but now we are seeing that the prices are actually coming together. The gap between the prices is narrowing down. Prices are closely coming together. That is one important observation. So we have seen how the prices performed during the last week. We have seen the performance of the physical market as well as the futures market. And we had a review about the geopolitical and economic settings of the markets, and which are the major factors which influence the markets, and either directly or indirectly, and what was the implications of the oil price, what was the implication of the Japanese yen. We have to remember that Japanese yen is currently ruling 6-year low against the dollar. And one point I miss here is actually dollar is strong now, remaining strong, and the dollar is likely to stay strong because in the next meeting of the US Federal Reserve, a 0.5% increase in the policy rates is likely, and the market expect in that way. So because of that that particular reason is keeping dollar high, and also the geopolitical tension and other uncertainties are also contributing together to the dollar, because whenever there's uncertainty, the investors they will go for safe haven currency like dollar. So that also is partly supporting the dollar. So dollar is remaining strong, and that is a negative factor for commodities and natural rubber as well. But yen's weakness will be supporting the Osaka rubber futures. More than that, RSS market, physical market, is actually experiencing tightness, and that also will be giving positive support to the Osaka RS3 futures. So what we can expect in the short term is that the Ukraine war further easing, if suppose we expect a further easing, that can have positive effect, some kind of a positive impact on the market. With the Ukraine war tension easing further, that can have a negative, can have a positive impact on the market, because sentiment will improve. So more investors will be coming, speculative investors will be coming into the futures market, as well as the global economic, actually the worries about the global economic recovery momentum will ease once the Ukraine war is easing, the tension is easing. So whatever happening, what is the further development in the Ukraine war is key to the outlook of short-term outlook of natural rubber markets. And the crude oil prices are likely to either likely to come down or stay at this level in the short term, and that will be crude oil price coming down will be a positive factor, because that will be supporting the global manufacturing as well as rubber demand, and also that will be helping the global economic recovery momentum by cooling the inflation. So this is a positive factor. Oil coming down at this stage is a positive factor. And we can also that the supply will be remaining low in the Southeast Asian major producing countries in the Southeast Asia. But in the case of Indian market, in the next 2 weeks, supply can gradually improve, and that means further increase in price in the Indian market may have some kind of a constraint. There are limitations because traders as well as the players in the market expect that supply will be improving, so they may be postponing purchases that can have some kind of a negative pressure on the Indian markets. So this actually in the short term we are expecting a gradual improvement in rubber prices globally, with the changes in the specific regional market. We are kind of expecting some kind of improvement. If the Ukraine war situation is continuing without a ceasefire, that means in that case we can't expect a major uptrend in rubber prices. But if a ceasefire is coming, it can actually translate into some kind of a considerable positive uptrend in rubber prices in the short term. So with that, I conclude. See you next week at the same time. Thank you very much.
That's about the natural rubber market review. Now we move to the next session, rubber industry business profile. This is a commercial part of the rubber industry news hour. In this session, we introduce the company and their profile. Today I'm pleased to introduce to you about the whole wheel components, a one-stop solution for all elastomeric needs. Let me show you their product presentation. And that's about the whole wheel components. If you are interested in their products and services, you can reach out to them. As I said, it's a one-stop solution for all elastomeric needs. The second part of the commercial section of the rubber industry news summary is a rubber industry buyer guide. This is a shorter version of the company profiles, company presentations, and their products and services. Let's have a look at the rubber industry buyer guide. Okay, that's about the rubber industry buyer guide. Let me introduce some of the rubber industry upcoming events. I believe that you might be interested and useful to you. Today I have two types of events I introduced to you all. The first one is IRC 2022. It's going to be happening during the 24 to 26 November in Bangalore, India. So let me show you the presentation of the IRC, International Rubber Conference 2022. Okay, that's the IRC 2022. Welcome you all to participate in this International Rubber Conference, which is going to happen in Bangalore during the 24th to 26th November 2022. I'd like to introduce the training programs of the Technobase Rubber Industry Training Program. I'd like to introduce April 2022 schedule. As you know, this is 365 days training. It means that every day we have one training program. Let me show you what kind of schedules we have in April. You may be interested, or you may have colleagues. Please have a look at this schedule of the April 2022. Okay, those are the training programs that are available during the month of April. If you're interested, you can reach out to me or check the website, knowhow-webinars.com. Okay, the final part of today's program is the rubber industry panel discussion. As you know, today our panel discussion is focusing on the present and future trends of textile reinforcement in tire and rubber industry. I think this is very useful and a very important topic, and so we have three experts today who will be sharing their experience and their input about this panel discussion topic, present and future trends of textile reinforcement in tire and rubber industry. I'd like to invite our first panelist, Dr. Barun K. Samu. He is a principal scientist at HASE3, India. He worked for HASE3 for a very long time. Before that, he was with the SRF Limited for many years. And also he did a MTech in fiber science from IIT Delhi. So Dr. Barun, welcome to the panel discussion.
Yeah, good evening, Peram.
Thank you very much for joining. Yeah. Let me invite our next panelist, Mr. Narapatidhar. He is a well-experienced rubber technologist with more than 45 years experience. And he worked in the tire industry, and also he worked in the tire cord fabric company, and currently he is offering consulting services for the rubber and tire industries as a technical consultant. Mr. Narapatidhar, welcome to the panel discussion. Thank you, sir.
Good evening.
Invite our last panelist today is Mr. Viresh Harmat. He is an assistant vice president at the Rajastri Poly Film. He's basically a division at Century Inca, a group of the Birla Group company with more than 30 years experience in the textile issues. So, Mr. Viresh, please.
Yeah, good evening, Param. Good evening.
Good evening. I need you to check your cam one more time. Okay, so welcome all. So we'll be having a good discussion on the what's happening in the textile reinforcement. Before we get into details, Barun, can you introduce a little bit more about yourself? What kind of work you are doing at HASE3? I think many of audience know about HASE3. Just a quick glimpse about HASE3 and then your current work, please.
Okay, HASE3, actually the abbreviation for Harishankar Singhania Elastomer and Tyre Research Institute. It is currently located in Mysore, Karnataka. It is promoted by JK Tyre and Industries Limited. It is an independent research institute and a CSIRO organizations. CSIRO means scientific and industrial research organizations recognized by DSIR, Ministry of Science and Technology. So HASE3 actually you can consider a one-stop solution for the rubber and allied industries. HASE3 is over 3 decades old. It is specializations in the field of a gamut of things. Example, materials for rubber and tire industries. So also the material developments. Then we have a test, you can say, a huge gamut of tests. Starts from rubber chemicals, product and full-fledged tires. We have predictive tools like simulations in the rubber, the engineering products, or rubber engineering products. and then we also do work on consultancy projects in Hasetri. And being an independent research institute, Hasetri's laboratory is also accredited with ISO 17025, which is accredited by NABL, National Accreditation for test and calibrations laboratories. So being an NABL accredited, Hasetri's test report basically recognized by internationally. Recently also Hasetri accredited for proficiency test as a proficiency test providers. So in brief, Hasetri has really a total basket for the who are interested in this field. Hasetri also does lots of trainings, like you also. And so far me is concerned, as you said, I am basically a textile graduate, then did my master's in the fibers, and since beginning from my MTech project till now, I am associated with reinforcement. So working either in the reinforcement manufacturers or the users of the reinforcements. So over 3 decades now. And worked in the product development when I was in SRF, and here also, as on the reinforcement material development. And I am also taking care of the laboratories, which consists of physical laboratories, chemical, environmental, and the new things like your Tyre forensic analysis. So whole sort of things are there. So that's about me in brief. Anything specifically if you'd like to know, please.
We will discuss more as we discussing various subjects. Yeah? Thank you, Barun. Thank you very much. May I ask Mr. Viresh? I see you have a Rajashri Polyfill. It's a division at the Century Inca. Then it is Birla Textiles and the Birla Group. Can you give us a quick overview about this company and also the product line as well as your current work line, please?
Yeah, good evening, Param. This is actually the Rajashri Polyfill is a division of Century Enga. It comes as Century Enga started in 1969, and in 1994 this Rajashri Polyfill started with a polyester actually here for apparel, this one saris and this one apparel fabric. Then it's moved in 2006. We started this tire cord industry. I joined from the start of this tire cord business here. We are almost a 90 ton per day capacity is there for the tire cord, and we are the highest in India for the nylon textile yarn, around 95 ton per day capacity. And it is a Birla Textile comes under the Birla Group only, but currently their business is entirely different from this one. Their controlling parameters are different. They're managed by the managing directors up in this one. Okay, this is all about this. I am basically a textile engineer. I am associated with this tire reinforcement from the beginning, more specifically with nylon only, actually nylon 6 only. But because of this diversification and this one, I may get chance of this nylon 6 and line polyester in future coming months only. That we'll cover in this one. That's all about me.
Thank you, Viresh. Excellent. So you know ins and outs about the Rajashri because you started there in the.
Yes, I was here from the beginning, from the flooring. Once flooring started, I was here from the flooring. Started with the 24 ton per day. Now we are moving up to 70 ton per day capacity now.
It's very good. Very nice. Very nice. Thank you. Mr. Narapati, sir, you are a veteran. I think these boys are, young boys to you, right? 45 plus years experience. You are in the tire industry as well as the tire cord industry. Can you highlight about your, experience briefly before getting to our discussion?
Yeah, briefly it is like that. I starting from the cycle tire company, then Mudirabar, which is currently known as Continental, then in Apollo Tires. From Apollo Tires, actually, I've shifted my profession to some extent, joined SRF Limited. And I was there for quite some time. In SRF also, I was looking after the technical business as well as product development. And of course, I must admit, it was a very, very tough job, especially when I joined in 81, during that period, nylon 6 plants or organizations were going through very, very tough time, very bad time. In fact, I can tell you that there is a total turmoil around 1990 onwards. We have to be, in short, 3 of the 5 plants got closed by 2005. Only 2 companies survived. Then came the third companies. Now, incidentally, India is very strong in nylon 6 fabric because we own, the risk-taking capacity and the proactive action. And after that, I was at Tyre. I was a field manager and also manager R&D. And sometimes I was working in compounding, and also I was in charge of the textiles. And there, actually, the textile means there was a slightly different than what is going on. I was overall in charge of textile, including laboratory up to the source development, either domestic or overseas. And it was strictly one stop. I was the person who was authorized to take any decision for that one. Only I had to, convince my superiors. They had the confidence, and I had a good time for that. Then after that, I was working for some time in marketing department, basically technical services of specialty fibers like aramide, rayon, and special coated fabrics, etc. Finally, I was in Apcotex Industries Limited, manufacturer of VP latex. And I joined there actually after my retirement only. And I must admit, I had probably the best of the times. I had a free hand. I was looking after on technical services, domestic as well as overseas. Then I was coordinating for different types of developments, and very happy that we could achieve a lot of things in Apcotex. And I retired from Apcotex about 1 year back. This in short, this one. So what is my qualifications concerned? I did my BSc Honors and BTech from Calcutta University, then postgraduate diploma in marketing management from Madras University.
Okay, super. Super. So we got a huge experience here, 30 plus 30 plus 45, 100, close to 110 years experience in the tires as well, tire testing card. I'm sure we're going to squeeze some juice out of your brains today about, the subject on the trends in the textile reinforcement. I have prepared 5 different issues today. We'll be discussing on these 5 key issues, and probably we may take as much time as possible for the benefit of the audience who will be joining today on the live, as well as the view later on on YouTube also. Okay. I'm putting my question onto the PowerPoint presentation for the benefit of everybody to understand. Okay, let's go with our first discussion point. And as you know, the tire is a composite product and a reinforcing material. It consists of the skeleton of the tire. At the outset of today's discussion, can you please elaborate where actually this reinforcing material lies inside the tire, how the functionality of the different reinforcing material differs from one component to other inside a tire. And this is important because for the benefit of the young new people into the tire industry or working with tire cords and textiles would be useful. Let's get to start with this one. May invite Dr. Barun to come forward and start on the issue, addressing this question, please.
Thanks, Param. Good evening again, and hi all, everybody. Good evening.
Good evening.
Good evening. You touched upon the word that composites, right? Where reinforcement, our reinforcing materials, that today's topic lies there inside the tire. We are well aware about the word called composites. So because in where we stay in and around, we deal with household goods, lots of items made out of composites, and most of them are like a fiber reinforced polymer composites. And another classic examples, our roof which is actually a concrete that itself is also a composite. So broadly, if you look at it, composites, what? In concrete, we know there is an iron rod. So we call it a reinforcement, and it is mixed with two other items, cement, then sands, and then some stone chips also sometimes. So together it makes the composites. So there is a reinforcing element, there is a matrix. So in this case, the matrix is the cement. Now, when we make the composites as a product, when we look at it, the properties, the characteristics, the performances are altogether different than the individual items in it. So we get basically a kind of very high impact, a strength, a kind of synergy we get it in a composite. Now, when we look the tire, for example, it's actually a composites made out of several items. That is rubber, but the matrix is the rubber matrix, which takes all the inputs in it. You have the carbon blacks, that's why we see is a black, that is silica many times. There are another 15-20 different rubber chemicals where it is getting fitted in the rim. That's a very rigid kind of a bead, which is a reinforcing materials. There is fabrics, which is our topic today. And there is in radial tire, there is steel. So if you look at it, some kind of so many items put together and put into the tire as a composite. So it's an amalgamations of different science and technologies put together. The complexities, you just imagine, finally the tire goes and runs in the service in the field. In case of a truck tires or an OTR tire, it takes tons of load with such a speed, with whole lot of abuse which is happening on the road. So somebody was telling, really, if you look at this product tire as a composite under the sun, maybe one of its unique thing or unique product which is subjected to maximum kinds of abuse and severity of those conditions. Still, customers' expectations, it has to run for 1.5 to lakhs of kilometers, and there must not be any kind of a failure. When you look at the passenger car, we are running at a speed of 80 hundreds. So what we are sitting inside the car, and the touch points between the road and the car is the tires. So for our safety, for our things running such a speeds, who takes care? It is the tires. And such a safety, high importance of that thing, tires. But unfortunately, we, the common people, really do not give value of these high-tech materials. Still, we look at tire as a black objective, like a simple commodity. The other day, I went to a Bata shop, to buy a shoe, which costs even over 3,000, 4,000, even 5,000 rupees. So I was just coming out of that. My family was saying, hey, you are like that. Why don't you today's like, it's a 3,000, 3,500, 4,000 is nothing like that. Now you look at a radial tire, passenger radial tires, whose weight is close to 8-9 kgs, and a shoe. Look at on the material per kg costs also. We are ready to give 4,000 such a money for buying a shoe, but we do not even bargain there. But for a tire, that giving such a thing, they are also a cutthroat competition. So that is why, if you look at it, the tire companies, you are a commercial man, you can look at it, the type of industries and kind of an EBITDA or profit things. Tire is one of the lowest margin industry exists. So today it's so much cutthroat competition. So what I'm trying to say, tire industry making such a high-tech product where something 8 to 10 varieties of different kinds of materials are there, which we are going to discuss today. And the challenge is that the product has to behave like only a total integrity, and that too with so much of speed and so much kilometers. So that's the, I would say, the unfortunate or the fate of the tires. But nevertheless, you look at the OE. OE means our original equipment automotive manufacturers. They are so much demanding today. And with regard to tires, what it was 10, 15 years back and now, it's a totally different things.
Sure.
So we'll discuss some of these things today. So I just, we can, if you present the first slide, which we are going to. So today, the first topic or the first top point, what you said, we will be touching upon. We talked about the reinforcing materials. So it would be really interesting to see where it lies. Some of the audience are from this industry, so maybe knowing also. Some of them working, but may not be doing, getting into that much details into it where it is. So let's go to the next slide. We will see at a glance what kind of these are the basically some of the key rubber composite products. Today's topic, of course, will focus on the tires, but there are products. So here are some of the key rubber composite products. We can look at it. So here's the tire, and so it's basically a passenger tire. Tire itself you can consider like a tire world. There are 30-40 varieties of tires, and each that varieties of tires are having a different altogether design, their materials, their performance, their finite elements, everything is different. Start from say 2 kg scooter tire to a 3-ton an OTR tire. So everywhere, some of the things are very common, like this reinforcing materials, they're rubber, those things are there, but design aspect, everything is different. So some of these key rubber composites, like passenger car, this is the sections. We will discuss more on these things. The V-belt, there is hose, conveyor belt, transmission belts. So these are all, we call it rubber composites, but one common thing we can look at it from, even from these pictures, that reinforcing materials are inside these things. So if you look at it, some kind of a similarity is there. What I talked about concrete, the reinforcement, the rods inside it. You look at our human body, you will get one similarity. Our bone inside, that skeleton, and there is outside flesh. So here in the tire, you can consider to that extent the skeleton is made out of this reinforcing materials. So from the skeleton, we can make it out also. What it gives the strength, gives the rigidity of the product. And rubber, which is coming in contact with the environment, with the road, with every rotation it comes into it. So that protects the skeleton, that gives the other flexibilities of on the products. Just can you guess what kind of a passenger tire in its lifetime, how many cycles it could rotate in a car in its lifetime? if you just think
number,
about,
cannot,
if you think about it, something it runs for say 40,000 kilometers.
Yeah,
it runs almost close to 45 million cycles. So that kinds of rotations, and every rotations it pass on like loading, unloading. So it's a classic complex dynamic scenario is there. You take about a truck tire, such a big tire, whose lifetime, with say 2 or 3 retreads, you can think about running for something around 2 lakh kilometers. Where again, it crosses some 50-60 millions of cycles. So while doing so, I use that word, you could able to see that retreading. So once the rubber gets abraded from the top and these things, again, the technology is that you can put the tread again, but the skeleton has to remain it. So basically that skeleton determines the durability, structural durability of the tires. So we will talk more on this in the subsequent things, slides. So now can we go to the next slides? There we will try to show what kind of reinforcing materials. So the first left-hand side pictures are showing our reinforcing materials of today's topic, and these are the pictures of the tire, and try to show where reinforcing material lies. So the first pictures, APCA, passenger car radial tires. So here there are how many varieties of reinforcing materials are there. You can see the carcass, because if it is the radial tire, many of us knows the textile fiber, textile fabric goes from bit to the other bit with the radial directions. So if you take the longitudinal or the axial rotations, it is 90 degrees. So bit to bit fabric is there. Over the carcass, there is belt. It is made out of, primarily today, it is a steel belt. And cap ply and carcass, these are in opposite type. Cap ply is 90 degree over the carcass. So it is on the rotational directions of the tires. And the other thing, I have put it in the circle, which is called a chamfer, and I will come on that. And this, which this part of the tire which gets fitted with the rim is called the bead. So bead is made out of another, you can say, a thinner diameter rod-like structure, which I tried to show here. So this is the most rigid part, so hardest part of it. Why it is required? Because it is in contact with the hardest part of the vehicle, that is the rim. And what is chamfer? Chamfer is there again inside it, which actually, when tire in dynamic conditions, that the outer part of it, it gets chafing. We call it as chafing actions. So chamfer actually protects from the rim chafing, with rim, the chafing actions, the inside fabric materials. This carcass is, it's get bound at one side of the bead to the other side. So basically chamfer, carcass, cap ply, all these are reinforcing materials and made out of fabric, whereas belt is of steel wire and bead is again a steel rod. So all the tires, irrespective whether it is bias or radial or OTR or defense tire, anything, you have to have the bead wire. Bead is the must. Now, when you look at it, fabric, these fabrics are not made out of the same fabrics. Carcass, when you look at it, for the passenger tire, it is the polyesters, where we will be discussing more on the suitability, how we are going to select different kinds of textiles for different applications. So here I will only touch upon what varieties of tire, fabrics are there inside. So this is polyester, this is steel, and cap ply, which is primarily made out of nylon 6/6. And this chamfer is the only fabric inside the tire which is made out of a square woven fabric. The picture from here, you can see square woven. When I say warp and weft, both directions there are nylon. And today this fabric is made out of nylon, primarily nylon 6. And this I am trying to show, this is actually in one directional, we can sometimes call it warp sheet. So this warp sheet is because the other directions is only of cotton wave, just to keep the positions of the warp sheet in an uniform conditions. So this is the warp sheet made out of either nylon or polyesters, depending on the applications. For bias tire, the second pictures what I am showing here, multiple layers of fabrics are there, and that is made out of this fabric. So it is the nylon. They are primarily either nylon 6. In Europe and some places there are nylon 6 also. And I talked about beadware, I talked about steel. Now, okay, these pictures let me also complete upon. So this is a TBR tire. TBR is what stands for truck and bus radial tire. With the evolutions of this radial technology, when you look at the TBR tire, actually hardly any fabrics are there. Conceptually, bit to bit, there is only one ply of steel fabric is there, one layer of. So imagine the complete tractor load coming only on one ply, and not complete load. I mean to say the carcass is one layer, and there are multiple layers of belts. So depending on the constructions of the tire, it varies. It can be typically say 4 belt designs kind of a thing. So below the box, I'm trying to show in terms of weight, what is the percentage of reinforcing materials for typically this for a PCR, this is for the bias tires, and this is for the TBR tires. Look at the steel percentage in terms of weight. It's close to 70%. Of course, because steel itself is heavier, whose density is close to 8. There is one more thing left here in the left hand side, which is the ready-to-use fabric, which is while evolving of these reinforcing materials, it came relatively much at the later stage. You can say this is an evolution of how to use this one. So with this availability of this ready-to-use fabric, you do not need a rubber coating process called calendering. Directly you can apply it on the tires. This ready-to-use fabric is specially made with special type of dip solutions and things, so where it gives stickiness onto it. So this is a very relatively new material, new things in this reinforcement journey. At the bottom, I'm trying to show here the summary. If you look at it, PCR, what kind of reinforcing textiles? Polyesters, rayon, nylon 6/6, and aramid with hybrid are used. That we'll be talking even specific things in more details. And this is for the bias things, bias tires. These materials are used. So in the subsequent slides, I wanted to, whatever I said, I want to show some of the real actual pictures, what are different types of tires inside the reinforcing materials. So the first picture is the motorcycle typical bias tire, where you can see from, because it's a cross sections, you can make it out. So this is basically the fabric layer. This is of nylon 6, which goes like this, and one end of the bead, it gets actually bounded. And this is a typical cross section for radial motorcycle tires, which is made out of rayon. And when you talk about radial, so there would be a belt, and the dominant player for the belt is the steel belt. And the below two pictures are one for the PCR, another is light commercial radial tires. So here the body ply, the carcass, that is bit to bit, it is polyesters. It can be rayon also, depending on many things, speed rating and etc. And there is steel belt. Here it is the LTR, light truck tires. Here the reinforcing body ply is made out of nylon 6. So it may be in your mind why in the one case it is polyester, another case is nylon 6. So that actually some of these things will be discussed in the next when you are putting it. I will touch upon here. So nylon, if you look at it, nylon 6 or 6/6, by inherently it is having the fatigue characteristics. So where there is more of a flexing load, etc., it is the nylon. And when you talk about dimensional stability, high speed performance, uniformity, so they are polyester is coming. So that is a better dimensional stable material. We'll be talking more on that. Just let us go to the next slide, showing some more pictures of different types of tires. So here the pictures of an actual bias tire, the left one, and the right, this one is RTBA tires. So here you can see again the 4 layers. I think it is a 4-layer belt and 1 layer of body ply steel cord. And here I tried to, what I tried to tell earlier, if you remember, the chamfer which actually put at this place, you may not be able to distinguish. So I tried to magnify it. You can see here where chamfer lies at the bead. It's covering the bead. It's covering the bead and coming in contact with the rim. If you look at it, outermost, of course, it is a rubber cover, and next layer is chamfer. So it protects the next layer, that is the body ply. So imagine such a very small component where chamfer lies from this to this, and performance of the tires finally depends on this. Like this, each and every component. So that's the complexity and beauty of this composite of tires. So that's the critical role playing a chamfer, which is primarily nylon. Why nylon? Why not polyesters? So if you ask why, there is an answer for that. Because nylon is better on polyester in this particular functionality. Because I have to cover that functionality. So each and everything lies. Finally, the answer is the functionality. When you talk about chamfer, it's a chafing action. That is why nylon, because it is better abrasion chafing properties than the polyesters. So it is like they are everything. So just look at few more cross-sectional things of the other tires. Let's go to the next slides. I think it is let's go to the next slide. Let us go. Yeah. So here, if you look at it, the first one, it's a 49-inch rim, right? OTR tire, a very large tire whose weight is more than a ton. And here it is not visible to great extents, but there are multiple layers of nylon fabric, what I showed in the first slide, maybe 16, 20 layers of fabrics. So because the load bearing capacity will be in tons. So this is the typical OTR tire cross sections. And so if you look at it, the inside material is what? It is polyamide, primarily nylon 6. Nylon 6 also used for some of the applications, especially nylon 6 we'll be talking later about the differences between 6 and 6. So where degradations, thermal stability comes into nylon 6, a better player than this. And this is a typical cross section. It's a very rare pictures you might not have seen. This is a cross sections of an arrow tires. And look at the configurations of the arrow tires. And you can see here how many layers of this side wall is almost full of fabric. It is only a thin layer of rubber inside it. So a fabric layer up to this, in the top up to this full of fabric layers. So and it is of nylon 6 is the key player of it. Imagine even close to 100 tons of a fully loaded aeroplane, when it is landing, what kind of scenario it is going to happen? Such a kind of impact, and it is being taken care by these reinforcements. And when this landing, they are like a truck tire, what we call it in terms of kilometers, but in aeroplane it is number of landings, because we all might have seen it. When it lands, such kind of smokes and things come out. So it clearly tells about it, what the temperature and the rubber experiences and what speed. So this and at the same time, finally it has to be a total integrity player. So on this integrity, I'll just touch upon something in the next slide. Just let's go to the next slide. So this is the thing what I'm trying to say. When we have so many things into it, if you look at it, there are many requirements, but broadly, if you classify it, you can get it two most key and the most important thing. One is the durability, which I talked about it, the structural durability for running lakhs of kilometers. another is the stability at the high speed. Now, where from it comes? So if you make a summary, that it comes from the integrity of the composites, because such a dynamic loading unloading scenario, if the adhesions between fabric, rubber, between steel and rubbers are inadequate, then there will be separation starts between either steel cord or rubber or fabric or rubber. Once it initiates, it propagates when it is in dynamic conditions. So in dynamic conditions, when I said about 40-50 millions of cycles are there, so your integrity has to be perfect, and this integrity determines the from the adhesions of the fabric and the rubber, or steel cord and the rubber. You might have seen in my first slide that fabric looks pink color. Why pink? It is that special adhesives treatment is there. You might have seen the steel cord, a brassy color. Why? It is a brass coated. It is not the original steel cord color. A brass is required for the rubber with the adhesions. Beadwear, it is again, it is coated with copper primarily. So that is a brass, and this is a bronze. So bronze is an alloy of copper and tin, whereas steel is steel cord. It is a brass coating, so it is an alloy of copper and zinc. So copper is primarily takes care of the adhesions front. So this is the most, I will say, if you go to the why and how, this is the second level which takes care of the integrity of the composite. It is the heart for the performance of the tire under dynamic conditions. So now if I summarize, making towards what I discussed, that if we ask what are the key functions of reinforcing materials, we have seen where it lies. So it maintains the structural durability against all kinds of bruise impact. So structural durability, if it is there, then only you can think about, even after the first life, retread and things like that. Then the second point, many times if we call it, which carries the load, we call it a tire. If we ask what part of the tire it carries the load, it is actually not the rubber. Definitely not the rubber. Rubber gives the flexibility. We call it reinforcing materials takes the load. Yes, but how? But next level, if you ask, actually the load is carried by air inside it. You might have seen, even in your vehicle, if tire gets little deflated, you give more air pressure to take the load. If you look at it, a truck which is taking 100% overload, they give the 15-20% higher air inflation. I mean, actually inflated pressure is more than the recommended level to get that overloaded conditions of that. Otherwise, it cannot get the load. There will be deflections into it. So what reinforcing material does? It actually, like a container, air container, right? It takes that kind of a pressure. You think about 100, 120 psi, that kind of a pressures, and it is not just normal pressure at room temperature. It is loading, unloading, temperature getting generated, and for a typical tractor, after several hours of running, the temperature goes as high as 130-40 degrees centigrade, inside the shoulder region. And heat is the enemy for the tire with regard to continuous performance, because if heat is there, that's the point when separation starts. So the other part of the functions of the reinforcing material on the steering, right? When we want to give a response, so tire needs to respond. So inside tire, the part which is touching on the road, that tread design, and that inside materials, that belt, that rigidity, how it is, that actually gives that response into it. And dimensional stability, when it runs at 80 kilometers per. We want to be very smooth when it runs on a highway or national highway. So this comes from the dimensional stability also provided by the reinforcing materials. And if you look at it, what are the characteristics of this typical reinforcing material? If you remember my first slides, all are in one directional. It is not like a sheet material. Cords are in. So length to diameter ratios is high. Strength in primarily in one directional, that is in the axial direction. So that's the tensile strength. And there is one twist. So twist which actually provides the fatigue life under dynamic conditions. So those are the typical things. I just wanted to touch upon these things. Now I think the final slide for coming to this one. Can you let us go to the next slide, where we are finally summarizing it. The next questions. Then okay, fine. Then what kind of cord properties we are expecting for kind of for carcass applications? Ideal. It's in a theoretical. You will not get whatever listed here. That very high tensile strength, modulus will be also very high. It would very tough, means very high impact. It must be very highly dimensional stability. So all this, like all these we call it a chutneys. You will not get in the same dish. So there will be always a mix of that, because like a God's rule, no? When the make like nylon 6, polyesters, rayon, so each is having its own some positive, some limitations are also there. So nobody is having all positives. So there actually those things will be described in more detail by our Narapatida. So that's the ideal what I wanted to say for carcass applications. But for the belt, it is again a set of different properties which is there, but here the belt means here still is the king. So when you talk about tire, still you can call it amongst all reinforcing materials like a dada. So in terms of volume, in terms of everything, so still it is the highest. And as we go on radialization higher and higher, so India today it's almost 99% radializations, close to 10% in passenger segment, whereas in truck segment it is still around 50 to 53%. So as highway goes, it will be more. So when it goes, still will be more and more. So I think that's all from my part of it, what you said. I don't know how far I could able to do justice. Please.
Wow, it's really good. Actually now I realize that textile is the important. Yeah, it's excellently presented, and you mentioned very nicely about the fabric required needs and the importance. I think the audience get a better understanding of what is important about. Mr. Dhar, you like to add any additional points? Yeah, please.
Yeah, I think that Dr. Samui has set everything in motion, and he has touched upon practically all the important points basically, and he has proved that he is really a textile person.
Yes.
So I do really appreciate, and he has set the momentum in motion now for further discussions.
Yeah, sure. Thanks, Viresh. You'd like to add any additional point here?
Yeah, thank you, Barun, because you have touched the fabric, how it is useful. I am with this nylon for the last 30 plus. You both have already in the other industry, but I am with the nylon. I am with the skeleton for the last 30 plus years. Thank you very much. You explained very nice. And one more thing, just I add to in this one. All the property very well, you have covered everything. In the fabric also, because I'm basically in the fabric manufacturing. The EPI distribution is also made a vital role in this one, especially high speed. When you go with the high speed, the EPI distribution of the cord plays a very high role in the manufacturing of the tire. Thank you very much.
Absolutely. So it's not only just EPI, because I touched upon only the peripheral thing, what materials. But when it comes to the design of the tire, it's EPI means ends per inch, or EPD we call it ends per decimeter. Then what angle it will be there, what constructions of the cord will be there. So it's a really a complex kind of thing. So each and every area, sub area or sub area itself is a mini ocean kind of a thing which gets into details.
Super. Okay, now we move to the next point of discussion. Let me project my discussion point to all of you. This I want to pose to Mr. Narapati there. Okay, and it's about the, as you know, there is a basket of reinforcing materials for the tire and rubber reinforcement. We'll get to go some historical evolution of how it is, because you've been there, 45, close to 50 years in this tire industry. We would like to know how to choose the right kind of reinforcing material for the target product application, and what is the current trend of usage pattern of the different types of reinforcing material for the different products and application. Mr. Narapati, please, I'd like to take your view on this. Yeah.
Thank you, Param, for giving the opportunity, and thank Dr. Samui, because she has set already the platform. And just start my discussions. Basically, see, of course, Dr. Samui has explained clearly. Basically, what is textile reinforcement? Just a short 1 minute. See, reinforcement literally means it is the improvement or enhancement. Textile reinforcement means the improvement or enhancement in properties, design properties imparted by these reinforcing materials. Now, if you look into it, that any development, we must look into the historical background to understand what is present and also to predict what is going to happen. Unless we have got a strong background of historical background, we will not be able to understand what type of work, enormous work has gone into it. This textile reinforcement, I think, is a classic example of it. Now, yeah. See, what about this is a chart. Of course, it's a small chart, but tells a lot of things. It says the actual development of reinforcing material was identified in early or end of 1890. Now, that time actually it was not suitable for the material was not suitable for tire. It was used for other industrial uses, but the reinforcement material was identified. The first breakthrough came when cotton was developed in 1900, and subsequently it was modified in 1920, suitable for tires. Now, if we look into the development of cotton for tires, and today it means there has been 100 years gap to reach to the stage we are in today. Now, why it has taken so much time? I personally feel the main reason is this synthetic textiles development is only a part of it. It would have to be supplemented and in line with the development in the rubber technology and tire technology. Hence, all the three developments have to go together. The single does not make any sense. Now, the other point came that, that, for example, along with that, another development was required, because it's not identified earlier when cotton was used. There, the bondability or the affinity of the reinforcing material to the rubber compounds. Cotton, there is no problem because it has got a physical structure which is called, it has got a lot of protruding ends, and it was forming bond with these protruding ends, which is called mechanical. It is a mechanical bonding, but it was okay that time with that one. However, when the next development came with rayon, in 1938. Then what happens? Synthetic fiber has been developed, but it was found that it was not adhering properly with the rubber compounds. And that was probably one of the most critical development in the history of reinforcing materials. Fortunately, General Tyre and his subsidiary, the Gentech, came forward and developed the dipping solution, which Dr. Samuel also mentioned. Very, very interesting point is, it is roughly probably about 80 years that famous defect solution, even today it is continuing. And nobody has been able to make any basic change. In fact, what a lot of developments are going on right now, but the basic structure remains same, though there is new developments have come up to replace one component by the other, change or because of various reasons. Then the next fiber, first, the improvement was made when rayon was developed. Incidentally, rayon is not a synthetic fiber. It is not called a synthetic fiber because it is better known as man-made fiber. Main reason being is main source of natural origin wood pulp. And with the development of the dipping technology, rayon globally started usage from 1940s. Now, during that period, another development came up of nylon 6 and 6.6. It was by mid 1940s, these two developments took place, and because of the good properties or the desirable properties of nylon, it caught on very well, and it was practically used. And during that time, another development came of the steel tire cord. That time, initially, it's a well-known fact. Radial tire was developed in Europe, not in USA. It was developed by Michelin. To be precise, it was commercialized in 1948, and it came to this USA later. In fact, there was a gap in between, though I'm slightly digressing. It was like this. In North America and others, the people could not switch over from bias tire to radial tires because of the investment. Even US companies were in trouble because they have invested billions of dollars for bias technology. When radial tire was sweeping the whole world, that USA and part of North America, South America, they had real problem. As a compromise, what they did, they produced a tire which is called hybrid tire. It is basically a compromise between the bias tires and the radial tires. In fact, it was quite popular there for a long time till they could develop radial tires on their own. So as the reinforcement is concerned, major development came was polyester. Polyester was developed in 1962. However, from the chart, though we can see the highlights here, major reinforcing materials have been identified. But one very important point is, even today, some of the major reinforcing material, today is not the same material which was developed 20, 30 or 40 or 50 years back. Classic example is rayon. Even rayon was modified in 1975 for better tenacity or strength. Then only it was found to be more useful for the tires, especially the radial tires. Another classic example is the polyester. Polyester was developed in 62, but today what we are using, HMLS, the latest polyester, it was only developed or fine-tuning was given in 1995. The same is true for steel tire cord. Today, probably the 4th generation steel tire cords are being, used. There, of course, there are a lot of other details are there. Of course, that will be very relevant right now. And the other point is there are also some potential new fabrics have been developed, but it has not been commercialized so far. Then now let us go to individual reinforcing material, see what is the positive points and negative points of each the reinforcing fiber. To that one, it is very clear there are 5 predominant reinforcing materials are used, not only in India, it's practically globally. Out of which nylon 6, nylon 66, rayon, polyester, and aramide. Now we will examine each one of the reinforcing materials separately in the next slide. Now, nylon 6. This nylon 6, of course, it has got tremendous advantages, attributes like very high tenacity, very good impact resistance, excellent fatigue, then lower density that I will explain later a bit in more details. And above all, it has got very good bondability with rubber compounds, of course, after the dipping treatment. And these qualities, including the high tenacity, makes it very, very suitable for bias tires. In fact, to the best of my knowledge, most of the bias tires are produced today with nylon 6. And so far as India is concerned, India is in a very, very strong position so far as nylon 6 is concerned. Here, I will just give you only one example that how the paradigm shift was taken place. That my own experience, because I was in the source development responsibility, I had to visit China, Taiwan, and other South Asian countries. It is the end of 1990, starting from the middle of 1990. China probably was the largest manufacturer of nylon 6. To give an example, the enormity of this scale, two tire cut companies, besides that they had a number of other slightly medium and smaller tire companies. One company installed capacity was 75,000 metric ton. Second one was 55 to 60,000 metric ton. Incidentally, that time, during that period, total capacity, Indian capacity of nylon 6 was only 40,000 metric ton. That is the scale they were operating. But paradigm shift, why I'm telling, later I had a chance to discuss with some of my professional friends in China or with whom I had contact. Later, by probably around 2015 or even earlier than that, it was found that drastically nylon 6 production has come down. Today, practically, there is shortage of nylon 6 here in China. What it means, there has been a paradigm shift, not only in China, in all developed countries, except probably the developing countries or countries where nylon 6 still is the most preferred reinforcement, mainly because of the production of bias tires. Now, of course, everything is not blessing for nylon 6. It has got its own shortcomings, like it has got higher shrinkage, it has got a lower modulus, it has got high growth during use, and main issue, it has got a dimensional stability issue because of lower modulus. Hence, nylon 6 has never been used for radial tires. Now, let's go to next slide. Now, it is nylon 6. In short, nylon 6 has got all the properties of, practically all the properties of nylon 6. Additionally, it has got some highly desirable properties. One is it has got a lower shrinkage compared to nylon 6, and also it has got very good thermal stability, which might be to some extent related to the higher melting point or softening point of nylon 6 vis-a-vis nylon 6. Now, this age has created a real big difference. Now, nylon 6 is globally used and is practically the only choice in high-speed, high-performance passenger tires for Capline. Probably there's no competition as such right now, but some competition may come up in future. The second one is that aircraft tires, nylon 6 even today is the most preferred material, probably globally, because in one of the seminars I was told that approval of aircraft tires, it takes 30 to 40 years only for approval purpose. As all the companies are trying, imagine their political trials for the nylon for aircraft tires of different construction, but it's a very, very long process. Incidentally, in India, Dunlop was producing the aircraft tires till probably end of 1990s. Unfortunately, the factory got closed, and today aircraft tires is not produced. And I was also told, as Dunlop India did not have the adequate testing facility, every lot, one tire is to be sent to France for testing and approval. Then only these tires were released to the market or sent to the government or supplier. But there is a positive side. Government of India and some of the tire companies are showing a lot of interest to go for aircraft tires. In that case, the only choice will be nylon 6. Then in some of the Western countries, developed countries, nylon 6 sometimes is used for truck, bus, LCV, farm tires, because it is believed that it gives better performance compared to nylon 6. Then even in non-tire sector also, nylon 6 has become very popular. In one of the application is the conveyor belts. In conveyor belts, that we'll discuss later, but one of the very popular construction is called EP fabric, where warp is polyester and weft is nylon 6. And probably this is the most popular construction for conveyor belts. Next, please. Now, this is another miracle reinforcing material. Rayon was developed in 1938, and it was really picked up for practically all types of tires, starting from bias tires, starting from scooter tire to our OTR tires, farm tires, everywhere. In India, Rayon was introduced probably end of 1960s, and Rayon was used for almost all tires. Rayon, nylon 6 was introduced in India at the beginning of 1970s. Probably exact year could be 1970. Sorry, 1940. Once nylon 6 was introduced, it started replacing Rayon from the bias tire market. In fact, at the end of 1990s, or the beginning of 1990, the Rayon was totally moved out of the market for bias tires. And that point of time, it was felt that the two plants we have, even today, there are two plants in India, that this is dyeing fabric. It does not have any future. In fact, the two plants I was told that it was about to be closed. Surprisingly, not expected, there was total reversal. Around 2005, rayon came back with a bang. Initially in Europe, later globally. Now, rayon practically is used for all high performance tires, including like ultra high performance tires, including non-flat tires, racing tires, etc. And most interestingly, rayon price probably is the most expensive reinforcing fiber other than aramide, which is roughly double the cost of nylon 6. But today it has placed it in a very high position where rayon probably will continue. But it has got its own disadvantages. Probably because of that, actually it was moved out of the bias tires. One is the lower fatigue compared to nylon. That another problem is the wet strength. When rayon is wet or it contains higher moisture, it loses properties. Then we see that also discuss that it has got a very high moisture again. Though it is not basically a technical point, of course partly technical, but main thing that it has got a very high commercial implications. Because when it is 12.5% moisture against 4% of nylon 6, they obviously the customers will have to pay only for the moisture. Then I think the next please. Now this is another fiber which is totally practically ruling the whole world today. Polyester was developed in 1962. As we discussed, because HMLS or high modulus low shrinkage material was fine-tuned in 1995. Today, that is the only material that is being used. Now, it has got tremendous attributes. Hence, despite its limitations, probably this is the most popular reinforcing material for, especially for passenger car radials throughout the whole globe. Now, here the attributes are very clear. It is that it has got a high modulus, it has got very low shrinkage, and because of which it has got tremendous dimension stability, which is required for the performance of especially high-end radial tires. But it has got certain quite serious negative points. For example, is inferior fatigue as compared to nylon, and accordingly, because of these fatigue properties, polyester is not used for truck and bus tires. Now today, HMLS polyester is the ideal reinforcing material for carcass of passenger LCB radial tires, and it has got a usage in other rubber products or industrial products also. One is very interestingly is that we have discussed about the conveyor belts, but it is used even for B-belts. B-belts, it is the only referred material. If we talk of basically that cost, this is one of the most suitable material for V-belts. And to my information, polyester also sometimes used for certain types of hoses. Next slide. Now, actually, out of the series of 5, this is the last reinforcing material. The aramide was basically developed in 1974. That time there was only one plant. Today, of course, there are 2 plants, and third plant also is operating right now. Now, it has got unique properties. For example, it has got the highest tenacity or strength in this group of reinforcing material. Very high modulus, low shrinkage, and excellent thermal stability. Unfortunately, it has got its own limitations. It has got an extremely low elongation and fatigue, poor fatigue. And other point is because of the high modulus and stiffness, the processing of aramide is very difficult. It will have to be done under expert guidance, or a lot of precautions are necessary for handling the aramide yarn or fabric. One of the most serious deterrent for this fiber is the cost. Today, I don't remember, I've not checked it out. I was dealing with aramide for some time back, maybe about 10 years back. That time, aramide yarn price was $20 per kg. And deep fabric cost, or rather price, was 40 USD. Now, I personally feel one of the main deterrent of aramide is the conversion. See, these companies, they don't do any conversion of their own. They have got their own converters. And these all converters are based in Europe, mostly in Europe. And their conversion charges and other charges are extremely high. It is my view that unless some sort of conversion facilities are established in India or so, probably the price of aramide in useful form, it might be very, very difficult. In fact, twisted yarn cost, the mind-boggling. It is much more than the regular yarn. Hence, this is one of the major deterrent for use of aramide, especially in India. Now, one thing that it will be touched upon later, one of the possibility or potential is that hybrid cord. A lot of combinations have been tried. I remember it probably starting from 2000 or so, a lot of work was done in various companies. Polyester, aramide, nano 66 aramide, everything has been tried out. And it has been, technically it has been found okay, but somehow it has not been implemented in a large scale. As Dr. Sami was mentioning, it has got a potential for high-end belts, high-speed, high-end belts, especially that for weight reduction. Because when the lighter tires are required, aramide plays very, very important role. Today, I think in some of even the bicycle tires, I was told that for racing used for racing bicycle tires, they are aramide. Some people are using aramide, so they become very light, and it becomes an advantage for them in the race. And as such, this is the discussion on the individual fibers. Now we will go to the properties. Next, please. See, this is a very, very interesting graph, which is called actually stress strain curve. There, all these reinforcing materials we have discussed have been included, and it is mentioned clearly also straight curve is the fingerprint of reinforcing textile. And most interestingly, each fiber has got its own distinctive curve. In fact, it also proves that each reinforcing material has got its own advantages, own disadvantages, and one is different from the other. And as such, there is no reinforcing material has been developed so far which has got all the desirable properties or optimal properties. And some people sometimes, jokingly or otherwise, this graph is called EC of reinforcement fabric. Next, please. Now we have discussed in qualitative terms, but this is a chart where it shows quantitative comparison between the different textiles. Here, number of parameters are there. In the x-axis, it is the parameters. In the y-axis, it is the reinforcing material. To touch upon only a few points that which is of relevance. One is, if we talk of density, we find rayon as the highest density, which is a disadvantage for rayon. Then followed by aramide. Now, melting point or decomposition temperature, here aramide is the highest. Of course, still we are not we are not discussing here much. And it has got the highest, followed by polyester, very closely followed by nylon 66, and then rayon, and ultimately, actually, the melting point of nylon 6, which is the lowest. The next parameter is very interesting or very important, which is tenacity. Tenacity, it is basically graph by denier, which is the strength per unit weight. Here, aramide beats everybody hands down. It is the highest, and it is roughly the double of that of nylon 6 and 66. And polyester, of course, it has got moderate tenacity, and so far the use is concerned, this tenacity is okay for polyester as such, because it is used only for radial tires. Then initial modulus also, we find aramide is the highest as expected. Then moisture again, this is another factor which we have been talking of. Now we find from here that rayon is 12.5 is the highest, which is a disadvantage in terms of technically as well as it has got a commercial inflation. Last property, it is considered probably the most important parameter of reinforcing materials. There is this hot air shrinkage. Here again we find, as far as aramide is concerned, and very closely followed by rayon, 0.1 and 0.2%, beats others hands down. Hence, it also tells the same thing in a quantitative term, that as such there is no ideal reinforcing material, and each reinforcing material is different from the other. Each one has got its own advantage and disadvantages, and it is depends on the tire engineer or associate departments to decide which material to be used for what end use, what size of tires, what type of tires, what size of tires. Next. Now, as such, this is the last graph. In fact, it is the most important graph. What it shows that selection of reinforcing material for our products. That is, currently, what are the reinforcing materials used for a particular tire? To give an example, suppose it is scooter and motorcycle. It is as expected, it is nylon 666 or PET. But I think that nylon 66 definitely is a preferred material, but it is not economical. As for my experience, recently I had experience of using nylon 66 in scooter and motorcycle tires at one point of time in my career. The only advantage that we were claiming was the higher productivity because of the higher melting point, where the curing cycle could be reduced. But because of the cost factor, somehow it did not continue for a long time. And another reason was this nylon yarn or fabric we are getting from Groupon, the company, but they stopped their production of nylon 66 in India. The second one, let us talk of farm tractor carcass. Here also, as expected, nylon 6 and 66, depending on the type of use or the sizes. Otherwise, nylon 6 is the most economical one. Then PCR. The PCR, we know that as like a radial belt, it is obviously the best choice is only steel. Then Kepler, we have seen it is nylon 66, and of course the hybrid aramide cord is being tried, which has got a potential. Truck and bus, truck bias, as expected, it is 100% nylon 6 or bus tire. Then TBR, OTR, and others. The radial, the belt, all are steel, and basically here the next one is of course that OTR tires bias. Here also nylon 6 and 66. Here the choice is to use nylon 6 or 6s for very large size of OTR tires. As Dr. Sami was mentioning, a lot of people prefer to use nylon 6 because of the very high curing time, where there is chance of degradation of nylon 6. Then OTR tire, OTR bias, same. Aircraft tires we have discussed, only choice is nylon 6. In conveyor belts, of course, we have got a lot of choices. Like that, even today, nylon 6 fabrics are running because it is much more cheaper. Most popular construction is EP fabric consisting of nylon 66 and polyester. And incidentally, recently, aramide fabric has been found to be quite popular, and it is getting increased use even in India. This conveyor belts with aramide, it is for only premium use, in the sense mostly it is used in the underground mines where the service requirements are totally different, very torturous, and also the replacement becomes a very big issue. One of my friends, incidentally, in the belting industry, told me today some of the belts, length of some of the belts are more than 5 kilometers. Let us understand the type of torture or the service abuse these conveyor belts are going, and quality of conveyor belts will have to keep a pace with the requirements. Then other cities mentioned is that this one, that power transmission belt, where it is only the polyester. Then glass has got a very good application in that rubber products, especially the belts. Power transmission belt, timing belt, and lastly hoses. hoses today, that steel is used, but today for high-end vehicles, the aramide is the main choice, and for regular hoses, polyester is still used. One of my friends actually, who has been in the industry for a long time, he was telling, in the industry nowadays, there is a concept called fit and forget. For high-end cars, they do not believe in that, the car will have to be stored or changing a hose or small issues. They say that all the components are used for lifetime. And to understand the severity of the situation, they call the hood temperature, the engine temperature during continuous run, says it goes above 140 degrees centigrade. Hence, normal reinforcing materials are not suitable for that. Their only choice basically is aramide. For hoses, most of the hoses called pararamide or regular aramide is okay, where it can bear the temperature of 150 and above degrees centigrade. But there is a special hose in high-end cars for cooling the hot air and circulation. It is called turbocharger hoses. They are even pararamide is not enough. It uses this special type of aramide called metaramide, where it can bear a temperature of 200 plus. Now, with that, I would like to conclude my talk today, and thank you a lot for your patient hearing.
It's very nicely mentioned with all the positive and negative attributes, and also the various reinforced selection. You put very nicely, sir. Thank you very much for sharing your insights on this. And
Thank you.
Mr. Viresh, would you like to add any additional points other than what Narapati has mentioned?
Only I want to add this one. I think Mr. Narpad has used all the material, whatever he has explained. I think he has covered everything he has used. Yes.
And Dr. Barun, what about you?
Our Narapati covered quite a bit details. I would like to only emphasize two things. A designer, when you are designing a product, like we talked about composites, you design a conveyor belt, you design a tire. So the two slides which our Narapati was showing, one was the stress strain curve, the other one is the matrix of the properties. I usually call it, that a stress strain curve is like our human body is a ECG. So if you call it really ECG of a fiber, you can get that kind of. So it actually tells about the character. If you just put that slide in front of you, and you can actually talk a half an hour on that, which one is what, you can just characterize on that. And in addition to that, when you have this matrix, a designer only pick which is the right one for which applications. I will now just to give two examples, and that too for a change I will not tell Tyre, because we have that today's topic on other rubber products. Like you look at the conveyor belt. In the same conveyor belt, the warp is made out of polyester and weft is nylon 6/6. Question is why? In the same conveyor belt. If you put opposite, it will be disastrous. So the designer should know what is important in the what direction. Here the most critical thing is the growth, that is the creep. Where both, that is 6 as well as nylon 6/6 have the disadvantage. So you can't put that. When it comes weft, you need that straffability. It's called that conveyor belt, because whole lot of materials has to come and hit. So there you need to have that elongation properties, right, to take more of a load, at the same time having a good heat resistance properties. So their polyester will not work, and nylon 6 will not also work. The other example you take, the timing belt. Now even polyester which is having a very good properties with regard to growth, means it is having less growth. Still, it will not work in a timing belt, because you need actually a zero growth materials. There is perfectly no growth even after running of millions of cycles. Their glass fiber is the choice. So this is the thing, or the topic which Narapatita was telling, the suitability of that reinforcing material for designing that particular product. So this I just wanted to emphasize it. Thanks.
Yeah,
Yeah.
it's
Thank
nice.
you. Thank you. Thank you.
I mean, I'd like to ask here, you did not mention about, I think, there's like EV vehicles now, electric vehicles, what kind of the tire requirements. And what are there any changes in terms of the reinforcing material requirement for the EV tires? What's like now?
To me, you are asking?
Yeah, the rubber, yeah, go ahead.
Yeah, you can take it. You have some time industry
So,
now.
so Piram, I will just request you to wait for that, because after the next this thing, the
Okay,
topic
we
is
can.
there, what's going to come in future. So there,
Okay,
the
fine.
vehicle technology for the future is EV, and there I am going to touch upon that. Okay.
Okay, fine. Okay, fine. Yeah. So
Perfect.
I'm a bit hurry. Because when you look at the table, you covered a lot of products, a lot of tires and all types of, hey, I didn't see the EV tires. That's okay. Let's move on to the next discussion point. It's on the about India. How India is placed with respect to the Make in India of these reinforcing textiles. What is the future prospect of these major the three reinforcing textiles, nylon 6, nylon 66, and the polyester in India? I think I'd like to pose this point to Mr. Viresh. Viresh, over to you.
Hey, thank you, Baran. In the backdrop of recent pandemic and the current geopolitical turmoil, Make in India has become even more relevant actually. Okay, it's like Make in India was there earlier also, and it is more focused on 2018, and it has made compulsory when the pandemic started. It's more especially after the complete lockdown, everything became a vacuum. All tires, manufacturing, everything stopped, and they become a vacuum. After that, it's completely changed. Government is providing all sort of support to the Make in India initiatives. Example, tire import has been brought under a restricted category, and duty exemption on PTC import has been removed. Earlier, only 5% they have to pay. Now it has gone up to 20%. The original with the exemption has been removed, and this productivity linked incentive schemes have been announced. We can see this last March month. You can see in the last 2 days paper also. No? The GST was highest collection of GST in the March, and it's 1.42 crores. It's the highest ever GST. It indicates the production has been increased throughout the India. And even with this export also, no? That it has covered 417 billion in the export, and especially in the March, it has gone up more than 40 billion. It is the last one actually. And for this, the local industry is well established in terms of the reinforcing textiles and has the technical capability to offer international quality material. It has been proven during the last 2 years actually. Best in the class manufacturing technology is developed, deployed by all Indian companies, well established in this area. We have all these established research institutes like Hasatri. You have seen everything, na? The Hasatri, whatever can be done in the Hasatris, Sashmira, and further supporting through industry body like IT, ITTM is almost 10 years old. It is governing, helping this one. With this, the China plus one policy also, na? And more recent Eurasia crisis tire manufacturers are looking inwards. They are looking us towards there, especially for this one Euro tires also nylon 66. It is not in nothing is there in nylon 66 in India. There everything is they're focusing more for the local this one. This has given the confidence to the local manufacturers, and capex has been planned for the expansion as well as the diversifications. Actually, last 30 years my career, I told earlier, I was with the nylon 6 only, but some part I've touched in the earlier 2 3 years only small quantity of polyester and nylon 6 but mostly within 1 year we are touching with a very good quantity. In Indian manufacturers will come up with the nylon 66 as well as the polyester also. And this, and I will cover up the major three. Both my panelists have told how the tire has been made and what are the all the properties who is selected, what the end, who is making money out of it, who is doing ruling the business. That will I will cover up in especially in more in India. I will cover up in the more in India.
Okay.
Yeah, this one, the nylon 6, it is actually today, the last year consumption is almost 150,000 tons per annum actually. If you go to the last 2011 or 12, it is around 211 106 kilo thousand ton was the consumption. There is no growth, but there is also no degrowth also, you can see in this one. It is because of the radialization. Radialization, when we saw it 2011, the radiation, we thought that it would go in a very high speed. I quote with on some example my experience in 2011. We started by our dipping production actually in 2011. Then as a customer, as a supplier, we visited some tire manufacturer. During that, because earlier I used to do with we deal with only the gray fabric, only up to the dipping process at the tire company. When I gone there, we explained about the dipping, whatever we have done on that. Then I requested that plant head, technical head, I would like to see this bias tire manufacturing, if you permit that. Then he suddenly he shocked and asked, wait a minute. He called somebody and asked him, take him to this all tire manufacturing. What the process bias tire? How? Because only because he may not able to see it, because after during his next visit, this is the concept at 2011 or 12 it was there actually. But by surprisingly, we are doing it much better. 2011 12 it was around 100 the 110,000 ton was the consumption. Now it is touching highest around more than 150,000 ton in this year. In this one, growth also mainly derives from the medium and heavy commercial vehicles, farm and two-wheelers. Radiation, actually, I told already, radiation for the last 3 years, especially from the 1920, 2021, 22, it has just moved from 50 to 53%, only 3%. You can say around the 15, 16, it was around 36. Now it is around 53. And the main growth and the growth, we can say around 4.6 CAGR is there in the OTR in the 2-3 vehicles, especially in the LCVs, because it is they're moving in the very short distance, that it may not be cost economical for to go for the nylon 6 or steel tire cord. Go to the next one. I'll touch up with the nylon 6 also. Actually, 100 now at present we are not manufacturing anything in nylon 6 in India. Why? As I told you, this all Indian manufacturers are coming with the nylon 6 production also. And this usage is around the main usage is in the Capla, as already showed explained beautifully by both my co-panelists. Yes, it is a Capla in passenger car, nylon 6 is in the Capla in paragraph. It is the consumption around 10,000. Out of it is around 4,000 is for the OTR and farm two-wheelers as well. Under this one explanation already as told, nylon 6 is a aero tires, and then all the defense requirement in India is looking for domestic supplies under the Atmanirbhar scheme. For that, everybody are gearing up to meet this requirement, present requirement. Major hurdle, as I told you, hurdles for the segment are consistent availability of the raw material, because we cannot go with a polymerization of nylon 6 it becomes a huge quantity. That quantity is not really utilized here. Therefore, you have to be dependent with some other, for the chips, dry chips or something. You have to depend with the other suppliers. We'll go to the polyester. Next one is regarding the polyester. Okay, I already told already the polyester, the PCR is already under radiation has gone up to 98, 99%. It has gone already. The consumption is on the overall consumption around 30,000 ton per annum actually, but nothing is made in India actually. The primarily used in this carcass, passenger car, radial type, and two-wheelers, as you explained earlier. This one, this one, now it is both all the tire manufacturers, the spinners are coming up with the polyester manufacturing here. Definitely, we are going with all tire manufacturers, reinforced manufacturers are going the latest technology or state of art technology. This one, definitely earlier it was there. Meeting with the cost was the main of this one to go for this polyester, because of the latest technology and there is a less availability. Definitely, India will do much better in the coming years in this one. The imports are mainly from the China and Vietnam. That is the main reason the India is looking for the expansion in the coming years. Tire industry, the fresh capex are main segment, estimating good demand in India from the OEM and replacement market. Especially this one, the nylon 6 is going with a replacement market around 60 to 70% is there. OEM is looking for the steel tire cord and this one. And even with the new capacity, the capex, India is able to meet all the requirement of the Indian tire industries. I hope I covered this your question. I think to make in India.
Excellent, excellent. How about the price? How is the price now? Is keep on
Price,
increasing?
it's not increasing to that because of this logistic. All the prices have increased here actually. There is an increase in the price. They both have the similar proportionate increase because the steel tire cord is also similar, and with the nylon also is similar. The availability is also one of the main thing what we are actually now.
Okay, Mr. Narapadar, you'd like to add any other points on the, make in India? Yeah.
Yeah. Mr. Hirama, see, you mentioned about polyester. In the same way, it is about nylon 66. See, the companies supplying this material are all global giants. For example, that polyester is mostly you are mentioning from Vietnam. See, Vietnam as such, they don't have any polyester factory. See, Vietnam is working just like as some sort of conversion center. These conversion centers are basically of Hyeosung, Korea, and Formosa Tapara, Taiwan.
Yes.
Two of the largest manufacturers in the world. Secondly, that India has got trade understanding with Vietnam and Southeast Asia, where the concessional duty are applied. What it basically means, the landed cost of polyester and nylon from these places definitely supposed to be much at a lower level. Now, when you are studying, you are taking, of course, enormous efforts you are doing, and I only hope and pray that you become very successful for nylon 66 and polyester. But the question is that how you plan to compete in terms of price. See, today that it is expected that anti-dumping duty and others will not come because it takes a very, very long time, like nylon. Nylon came probably after 15, 20 years. Now here, because of the availability, anti-dumping duty and other concession will not be applicable. Government cannot do it because there is international understanding. But how do you think that you will be able to compete in terms of price? Number one. Number two, see, whatever we know tire companies are very fussy, working in tire companies for a long time. The approval process is generally sometimes is very, very long. But how you think that you will be able to manage this too? Because whatever the tire companies are telling, they would say, look, we'll produce tires, send it to the market. The feedback will come after 1 year. Passenger car, the feedback probably comes after 2 years. But basically, how do you think that you will be able to compete in terms of price? Because of the low productivity.
Yeah, I'll ask.
Yeah, please.
Yes, I will come up with this one. I'll go before this one. I will go with the nylon 6 only. It's regularly used. I told already 110, 150,000 ton is the requirement, and what we are making is around 110 is produced by the locally, and we are going expecting. When you see the previously, it was only 70% was 60% imported, and 40 was the local actually. It has moved now. It has reversed the case because of the increase in the cost of the imported metal, availability, and the this one. Similarly, the polyester also, polyester. When we started earlier, also it has been started by other companies and some other local Indian manufacturers started because the cost competitiveness was the main problem and the approval process. Nowadays, everything they have moved to the new methods of the approving method. We can say, I can give code now within the 3 months, 4 months. Earlier, to approve the dipping portion, you might be knowing, approve this dipping this one machine is to take 1 year, 1.5 years earlier. I can last both the machines in our this one. It took hardly first machine took only 20 days, 25 days because all the tire we are associated with the tire company. Along with them, it has been made and the approved only 25 days, because they have some different technology. Mr. Barud will explain much more about fatigue test and all this. They have made it in a faster way, and damage stability, they have checked it, and they made this one. And similarly, the second also we moved it within 1.5 months. Same thing is now with the requirement of the all, because it's not availability. You might be surprised during this pandemic, the nylon 6 itself is imported, airlifted. It's the first time I've seen in the 35 years. Airlift costing same thing. The cost of the airlifting was much more than the cost of this one. I think the availability is also more important, and reliability on the India local market. Emphasis on the local market has gone more. And definitely, it will. All the local will also produce, because the technology wise, I think India is not inferior, because we have recently we are involved with the all machinery equipments. We are using one of the latest technology, whatever available in the market. Even they are not coming with, we are coming with the new one. We are all coming with the latest technology. Definitely technology wise also we are superior to the other suppliers. That definitely I can assure. The quality wise as well as the price wise, the Indian producer will give much better product than imported in the future. This one.
No, you are right. See, you have got the latest machine, everything, but see, there is a scale of production, which is called how you plan to scale up the production. Suppose today you are producing 2,000 metric ton, but only do you have any plan to go for 20,000 or 50,000, where the cost of production will come down? Which, see, you imagine these overseas companies, they have been operating polyester, for example. Nylon 6, of course, these are very old product. Polyester, for example, are produced by the companies.
Yeah.
Their capacity is 50,000, 1 lakh metric ton per annum. This type of economy of scale. That is the only one point that sometimes bothers me.
Yeah, actually, the present actually, as I told you, just now, only 30,000 ton per annum is the requirement at present. As we estimated, because everything goes with a large scale. This one up to what will be that 2027, what will be at 2030. This all has been calculated and studied. It has for 2027, it may go up more than 60,000 ton, and even 30, it may go still more. On that basis, all the tire local spinners are planning for the expansion. Before coming the first one, they are planning for the next expansion also. Definitely it will cater to the whatever requirement.
Right. Yeah, I think that you have touched a very, very important point, that probably because of the high growth.
Yes. On that basis only the planning is going on that is.
Right. Thank you.
Super. Okay, let's move on to the next discussion point. Guys, if you're a little tired, I want you to get some drink. Okay, we'll be discussing as long as interesting story goes on. So we'll be talking about the next discussion on what is the prospect of high performance fiber like aramid, carbon fiber in tire and other rubber composite products. In spite of its noble concept, why did hybrid cord not become so successful in tires, and what is its future prospect? I'd like to pose this point to Dr. Barun. What's your input on this?
Yeah, thanks, Pairam. See, in the previous part already, Narapati talks about those key characteristic features of the individual fibers and things, where he highlighted about the aramide, which is exceptionally outstanding properties with regard to I will say two characteristics is unmatched by any organic or any synthetic fibers. That is the tenacity, that is the strength by weight ratio, and the second one is thermal stability. So if you remember his table, what he was showing, I don't know, you may not be able to remember. If you look at steel cord, you keep apart. The other all fibers, if you look at it, they are all around 220 to 250. That's all degree centigrade. So by that time they melt and the stability gone. Look at aramid. When if you remember the chart, it does not melt. You go on hitting, it will degrade at what temperature? As 500 degrees centigrade or above. So imagine this kinds of a property of aramid has. But then as such is very difficult to apply all things in a product like tire. But if aramid has tremendous applications in many areas, high performance applications. If you talk about it, a composite of aerospace and things, it is dominated player. Dominating players are aramid and carbon fibers. But tire is altogether a different ball games, which I touched upon in my first presentations, where it's kinds of coming all kinds of abuse in the world. Composites, load, heat, potholes like anything, and on the top of that underinflations, and then put more load. So in units of fatigue. So in spite of it's the best stress strain curve, when Raida Narapatida was explaining about the highest modulus, but it can't go into it. So it has the limitations of its elongation characteristics, its impact characteristics, its fatigue characteristics. So then there are a whole lot of research going on for the decades. So how this fantastic characteristics of aramid can be deployed to composites product like tires. So here came to retain the best properties, the outstanding properties of aramid. At the same time, how you can minimize or reduce its limitations. So that's what I just want to emphasize. That let's go to the next slide, where I touched upon that to utilize the two most the most positive attributes of it of aramid, that is what? Strength to weight ratio. So that's called the tenacity, and the excellent dimensional stability. I will say use this word called outstanding dimensional stability, because if you remember shrinkage, the table of the Narapatida, it was close to there is no shrinkage,
0.1.
and at the same time
0.1.
modulus was extremely high. So excellent dimensional stability, but still it could not find that much in tire product. So because of this fatigue and a low elongation and impact. So how to minimize these limitations? Then this concept came called hybrid. So there is a difference between the hybrid and the blending. So you are a rubber man, so blending. So you are blending with NR with SBR and or BR with SBR. So at that level, in the mixing stage, you can do it. But in case of yarn, when you made it, the physical entity is there. So hybrid cord is basically a physical. It's not a blending. So physical yarns are there. When you talk about a cord which is made out of 2 ply, here 1 ply is made out of aramid, while the other one is the other fiber. Now the question is how to choose the other fiber which can mitigate the limitations of aramid. And at the same time, you have to remember, this is also an engineering thing coming into it. Which one to choose? You have in your basket nylon 6, you have in your basket polyester, you have in your basket nylon 6/6 also. Our target is to how to enhance the elongation, impact, and fatigue characteristics. The choice came nylon 6/6. Question is why? Why not nylon 6? Because they are all polyamide. The question is, when you now look at the dissimilarities, because finally you have to bring the two cords together, 2 plies together. They are also, you have to see, in spite of its, there are huge differences in stress strain curve. What are some similarities are there? So when you look at nylon 6 and 6/6, the thermal stability of nylon 6 is very much inferior compared to 6/6. Look at the softening point. It is 180, 190 only. Melting point 220 for nylon 6, whereas 6/6, its softening point is over 220, and its melting temperature is 250 degrees. Why this thermal point is important? Because in the processing, when you make the cable cord and then go for dipping, and if you make nylon 6 with Kevlar as a hybrid cord, it will be disastrous. But at the same time, nylon 6/6 will give this elongation characteristics. So the curve is getting that y-axis close to almost straight vertical type of curve you are shifting towards x-axis, so bringing them more elongation characteristics. So here I would use this word. Basically, hybrid cord, the cord properties is not the aramide properties and not the nylon 6,6 properties. It is in between properties towards more towards the aramide side. But you get a good elongation. Where elongation character, elongation at break of aramide typically say 4 to 5%. In a cable, in this hybrid cord, you can get up to 15%. So imagine what kind of things are there. But the catch point here, when you are talking about the failure properties, go up to strength breaking level. So they are the litmus test is how they are breaking. They are breaking as an individual ply or they are breaking together. So this togetherness is very, very important. So here the twist optimizations and the dipping optimizations are the two most important thing to get an hybrid cord having a very good togetherness. So basically what you are doing in hybrid cord is not the inherent a new fiber. So the fiber chemistry remains same of aramide as well as nylon 6,6, but you are actually doing the cord physics, you are doing changing. So there is one chemistry, there is one physics. You are not changing the chemistry. It's not possible to do the molecular structure. I mean the backbone chain as well as the morphological structure. You are not changing. That is related to the fiber chemistry front. Whereas basically cord physics you are changing by changing the twists. Just what I said. To visualize it to some extent, I tried to depict in the next slide. Just can I have the next? Here, look at the top picture, which is showing the cord where this is a helical type. So you are this ply is having more twist. So more twist means when you are elongating it or stress applying it on the cord, this will get more elongation. So this a helical part is the ply made out of aramide, and in this one almost straight it is having twist but a lower twist, that is of nylon 6,6. And the below pictures is basically the dipped fabric level, dipped cord level. So try to show here also how you are optimizing the dipping. So this cord twist and this dipping optimizations made that aramide cord which is having better togetherness to get the good properties, having good impact, at the same time having very high tenacity. But in spite of doing so, still it has limitations. It cannot replace polyesters, it cannot replace 100% nylon 6,6 for applications like bias tire. If you put this even hybrid cord in a bias tire carcass, it will be disastrous. And put it into a road like Indian road and things, it can't. Still it will not. But it finds its applications for some applications. As I was telling, being a tire designer, you have to choose from the basket depending on the component where it suits. So for example, in the cap ply over the steel belt, as a cap ply applications, this hybrid cords today is being used for ultra high performance tire, racing car tires, etc. And being from the tire industry and being in the research domain, I used to do your benchmark analysis. So benchmark analysis means tire being a commodity product, I can pick any tires as per my choice and I can cut and test what kind of materials it is. I can do those benchmark analysis, reverse engineering kind of thing. So I find there, yes, global measures, big global technology giants, they are trying with this aramide, and I find one of the applications in that cap ply made out of this aramide. So I hope, Piram, I tried to touch upon. It has an excellent, outstanding properties, but you can't do that. It is too much for that. You do fiber physics and cable doing something, you are able to do, but still it has some limitations, right? That's all.
Yeah. How about the cost wise? Is it?
Okay. Cost is several times per kg when you talk about aramide compared to nylon, right? And polyester, it will be, again, you have to multiply by another 1.5, 1.7%, because polyester is the cheapest materials. But you may think about it, that means aramide has not much of future. Yes, it has futures, but not in tires. That I already told about. It has many other applications. High performance, bulletproof jacket, there it is, dominant player is aramide and the ultra high density polythene fibers. Yeah.
But the consumption is increasing over the years. What it is like now?
Over the years, yes, it is increasing, like mechanical rubber goods and hose applications. There are going some special, very thermally, where the product or what Darda was mentioning about the hoses in engines, where it is at very high temperature and things. Those I would say it's a very high end and special applications where the product manufacturers can take that cost of it, because they are going to get money from that product.
But I'd like to add up that another sector could be optical fiber. In fact, if I remember correctly, these aramide manufacturing companies, they have got separate section for optical fiber. Today there is a lot of expansion in optical fiber. So aramide, yeah, there is the pararamide, regular aramide is used.
Mr. Viresh, do you have an idea how much has been imported into India, this aramide? You got any data on this?
No, I'm related to nylon tire cord. Morely focus on the tire cord fabric and DCF more.
I mean, if you also getting alternate to the other materials.
Yes, other material, yes. Other material like nylon 6 and the polyester actually. Even with the steel tire cord also we are touching of the taste cord, because the total value of the business you see, around 7 billion is the total turnover of this one tire industry reinforcement. Out of is almost 60 to 70% is only steel. That is the big boss. That is steel is the big boss. Only we are playing with for the 30% only of the total business actually.
So, anything else to add, Varun, on this? That's all right.
I think that's all. Yeah.
Okay.
I think that then because of your patience, so much extended session.
Yeah. It's all right. We're going to one more important point: the future, the trends. So let's look at the final discussion point of this panel discussion. It's on what are the mega trends and key change drivers in tire industry for the coming years, how they are going to impact the reinforcement industry, and what is going to be the likely trend for the reinforcement in the future. I think I will ask Dr. Barun. I see that he's a textile man with working for Hasatri with a huge source of information. I'm sure he's working on the day in day out of all the things happening in this segment. Barun, over to you.
Okay, Piram, just at the outset, I would like to little amend. I'm not only a textile man. Actually, I'm a composite man now.
Okay.
I have on the education's knowledge qualifications point of view, I have actually both. I have that rubber technology diploma. I have the master's in fibers, and my doctoral in the polyester industrials, and working in the rubber industries. So it's basically a composite kind of a thing.
Yeah, you are a composite man. Let's put this way, recorrect it as a composite guy. Okay, let's go over it. Yeah.
So actually this the thing which is displayed in the screen, I'd say the most interesting front of the today's discussions point, and all our mind goes finally, okay, we are there, we are here, so what is going to be? Now if you look at, we are talking about reinforcing textiles and materials. But if you look at it, it does not have any existence. It is only going into a product. So as such, it does not have any say to I would like to be like that or things. Okay, if a person comes with a new product and thing giving to the users, he has a a designer have a new choice. But primarily it is governed by where it is going. For example, even what we are doing, it is for the customers, the next process. So if I put like this, the material is going into the tire, so its directions for the future is driven primarily, the major thrust coming from how tire is getting, in which direction it is going, in which direction the prospects are going. But ask the question once more. Tire also, you will not buy only one tire and keep it at home. It is going for the vehicle. So it is again governed by the tire trend, is also governed primarily by the automotive segments. So if we look into, the tire becomes the tier 1 supplier to the automotive manufacturers, and reinforcement becoming the tier 2 for the automotive one. So this is the chain. So whatever we talk about a trend and things, you will find there is a linkages, and I tried to put that linkages, how it is coming and how it is determining the future of the reinforcement materials and reinforcement textiles in a briefly way. So I have only 2 slides to show you. Let's come to the next slide, where I am trying to show here the mega trends or the future trends of the tires. Now here, one very interesting point has come. You will find not only across tire industry, not only across in automotive industry, it is everywhere. That word is sustainability. So whatever we do, we have to do in a sustainable way. So what is the definition of the sustainability? It is called you use less, consume less and use more. So that's one thing. The other one is from your existing things, how you are going to use, recycle, reuse, and regenerate, like that, renewable from the nature what you are getting into you. That's called the fiber. I am talking about the bottom one. So this is the layman's understanding when we talk about the sustainability. But there is another big factor is coming on the environmental front when we talk about sustainability. That's less carbon generations. So how we know that automotive is directly related to the carbon generations, about the pollutions and things. Then is there any relations with tire? Yes. In tire, one of the tire important performance characteristics is called RRC, that is rolling resistance coefficients. So a low RRC tire will give a better fuel economy. So if you go for several kilometers, so you will consume less of a tire which is having less RRC. So this is one of the very important directions today demanded by primarily by the OE manufacturers and tire industries. They have to design their products, they have to make more and more in that directions. Now when you look at a tire, what contributes in RRC? So there are several components into it, but of course the major contribution comes from this one, what is called the trade component, which contributes 40 to 50% of the RRC contributions. Then other components are contribute, a different magnitude, like 15-20%. Somebody's 10 to 15% like that way. Yes, reinforcement material has also a relation. It contributes on RRC. And one more thing, when you reduce the weight of the tire, automatically there is a relationship, and not a very straightforward relationship. It also reduces RRC. So that's what I put this one in a bold, this color. That means those points which are bold and colored, those have relationships on this slide having an influence on by the reinforcing materials. The other one, if you look at it, when I talk about this slide, the mega trends. So I talked about sustainability, this fiber. I now talking about fuel efficiency, vehicle efficiency, and another big thing on coming on the safety aspects. when you talk about tire technology, if you talk about new technology, there are always a linkages with the safety aspects into it. When you talk about smart tires, you might have seen advertisement in TV. Even JK Tire has an advertisement. They talked about tire speaks. It's a smart tire. So it tells about what is the inflation pressures now it is. So those kinds of things you can do it. And the other thing, smart tire is also related to this one, your self-sealing technology. We are talking about it. So it does not, there is a nail penetrations. All on a sudden, if it get deflects, so it is very likely to cause for an accident. So when you have self-sealing technology, so even with the nail penetrations, that leaks gets automatically repaired. So those are the new technologies coming. So I wanted to show in the tire also what are the things coming into the picture. So okay, self-technology directly does not have relationship with these things, but one should know also what is happening around it. The other aspect, safety aspects, it's called a tire leveling criteria. So this tire leveling criteria, there are three things which is basically, India is not far behind now. It is European things and American. They are very, there are these criteria are very strictly followed. One is the fuel efficiency, that is related to RRC. Another is weight, grip, and third one is the noise. Even noise is primarily, comfort and those things, environment related things. This also coming, in a strong way for tire leveling criteria things. So this is on tire technology aspects where RRC has a relationship on these things. The other aspect, which is related to biosource or natural sources and rich compliance. What is rich? It is basically related to restrictions of the prohibited chemicals. That is registrations, evaluations, authorizations, and restrictions of chemicals. So this is enforcing by European things, that anything when you are exporting it, you have to comply with the rich compliances. So more and more you have to make your product in such a way, environmental friendly materials and things. So here also there are a lot of research and things going on, and reinforcing material producers are also not far behind on this aspects. They are doing research how it can be more and more towards biosource materials, and also complying with the rich regulations. There are few chemicals which are of hazardous in nature, and what they are doing in this. So all those four aspects, what I touched upon here, highlighted here, it is a significant R&D involvement is there to come up with solutions to meet the future demand. So my second slide, I wanted to emphasize on what R&D things going on, what are the things at the R&D level, and what are the things from R&D level it has come and it is on the industrial phase. So let's have to the next slide, which actually talks about this one. So this is the intermediate one, which I talked about the previous slide, from vehicle to the features. So before coming to the last slide showing the feature, this one is talking about from vehicle to tire to material linkages. And Peram, you remember you asked me about the EV part. So here is, I told you to wait for some time. So here, if you look at it, the vehicle train, if you look at it from the IC engine things, it is the EV, your things what the EV. So look at the tire things also. So there are concepts. It's called narrower and taller, and sometimes it's the other way down also. So if you look at the electric vehicles, so what are the specialties of the electric vehicles? So electric vehicles, and what are the needs of that? So if you see, it is going to be heavier car, right? The same capacity car is going to be heavier because of the battery. And in an electric vehicle, it needs a high torque, especially at the initial torque, and high accelerations, which leads to high torque. And it is going to be very silent car, right? it is going to be much silent than an IC engine car. So these, and also safety is anyway there, high acceleration, high speed and things. So these are the things for the electric vehicle specialties there. Now, as such, I already talked about you the RRC front, that is the fuel efficiency. Now, if you look at the EV car itself, they are going to be extremely fuel economy compared to, energy efficient, I would say. So in that respect, then it becomes much more challenging for the tire manufacturers, because their tire RRC will be getting highlighted on overall, energy consumptions. So tire level, when you look at it, so these are the key things required for the tire, and the linkages I'm trying to show it here through the arrow. For example, when you talk about a high torque, it is going to do a high wear level. So wear and tear of the tread is going to be very faster. So tread compound development is a very big challenge for the tire industry. For the EV car. So now, when the other thing, it is going to be very silent car. So there are noises coming out of. If you stand, beside an highway, and if you look at the cars or the trucks moving at a high speed, and at night, midnight, you will find whole lot of sounds are coming. So tread pattern, their aerodynamic things causing whole lot of noise. So here also the tire manufacturers challenges are there. You have to make your tire design, tire pattern in such a way. So we have to reduce the tire noises there also. So here also a big challenge is there. So amongst all these things listed here, the key challenges are RRC, I will say this one, durability, wear, and the noises. So now if you look at on the material front, so compound development is definitely a big center stage taking it here. But when you see the linkages of the reinforcing materials for the tires for the EV, one on the RRC front, and there is connections with the weight of these things, because as such the vehicle weight getting reduced, so there will be pressure to reduce the tire weight. So reinforcing material being, if you remember my second slides there, there is a percentage weight of the reinforcing material, how you can reduce the weight of towards reductions of weight. So the mantra is there, reduction of weight means it has to be stronger and lighter. So develop materials, go towards super tensile, go towards ultra tensiles like those. And so high tenacity super tensile means the strength will be higher with relatively lower weight. So these are the connectivity with regard to the materials. So if you combine my first slide and this thing, so the center stage of sustainability and this vehicle technology towards EV, if you club together, then comes what is going to be for the reinforcing materials. That I'm going to say in the next slide. So Peram, please. So this is the thing what I touched upon already. Lighter and stronger is one of the key buzzword for towards lighter weight. So towards higher tenacity. So HT, high tensile, ST, super tensile, UT is ultra tensile. So these are the terms used for the steel cord, but conceptually it is there in textile also. So if example, you take polyesters, what Dharda was telling, the third generation. So we are talking about now fourth generation, fifth generation also. So those are at the R&D level. Somewhere it is coming at the industrialization phase also. So HMLS stands for high modulus low shrinkage, that is highly dimensionally stable polyesters. So towards a high tenacity further, it is called HT-HMLS, high tenacity, high modulus, low shrinkage. So so you are retaining those high dimensional stability, at the same time you are getting higher tenacity polyesters. So these are all the developments going on the polyesters. Now I would like to just emphasize here on polyester. Polyester is the only polymer under the sun which has the maximum flexibilities into it. Here the basic fiber chemistry, the backbone polymer chain remains same. The polymer monomer and the polymer does not having differences. Molecular weight and followed by the morphological structures, you are getting lots of varieties of polymers. So here two examples I just now told: HMLS, HTMLS. So we are talking only industrial grade. You have another several grades in the apparel grade. So the second point, is coming optimizations towards weight reductions that has connectivity with the sustainability, which I showed in the first slide in this top point. So construction optimizations, what Viresta was also touched upon. So this is not a generic trend, I will say, towards going higher and higher denier or construction. Example 1680 by 2 to 1890 by 2. Now people are talking 2835 by 2. So by doing so, what you are doing it, I showed there in the OTR tab 16 to 20 layers of fabrics. So going for higher kind of this constructions, you are actually reducing number of plies. So if you do reduce number of plies, meeting the tire engineering requirement of the overall tire strength requirement meeting, so you are reducing the tire weight. So by doing so, you are not only saving material on sustainability front, but also you are doing one more thing, that is reducing heat generations. How? Because once the tire mass or sidewall becomes thicker, the heat dissipations becomes a problem. So whatever heat is getting generating, it will get inside. Further, more generating, temperature rise will be higher. Finally, it will cause your initiation of separations. So it helps in two ways when you do reduction in weight. Then the third point, if you remember in my, I think it is first or second slide, I showed one ready to use fabric. So this is something, a relatively newer concept, and it is there already. People are using it. So here you do not need any calendaring process. Directly you can apply it like a bead wrap materials. So those are the special innovative product globally today done by only few manufacturers and directly offered to the tire manufacturers. This eliminate multiple processes of handling, calendaring, then cutting process, stock preparations. Directly you go and use it. So this is one trend which is already happening. First point I told you, something already happened, something happening. Now if you talk about the fourth point, tailor-made material to improve performance. So here just few minutes before I told polyesters, varieties of grades of polyesters, even within industrial polyester family being developed. So this is called a durable polyesters. Here aiming is, they are trying to get applications where nylon 6, for example, LTR and heavy duty passengers vehicles, like those kinds of applications, where normal polyester is not suitable. So they are trying to get a special polyester which can have better fatigue and things, which can eat away the market of nylon 6. So polyester competition, manufacturers of the polyester and the R&D, if you look at it, one of their big directions of R&D and things to get into new areas. The next point, if you look at it, tailor-made polyester for applications like motorcycle tire. The term is called nylon-like polyesters. So they make the polyester in such a way, the yarn stress strain curve, which is not like a normal HMLS polyesters. It would be more of a, it will not be exactly, but it is more of a nylon 6. So a lot of R&D work on, people are trying into it. There are challenges because after all, inherent thing you can't take away. So polyester, definitely they are big thrust in R&D to get these kinds of new products. The next one, if you look at it, compliance of REACH regulations, what I talked about it few minutes before. So here the problem of the hazardous chemicals, which I talked in the dipping, resorcinol and formaldehydes are used, which are hazardous with regard to environment. So there are regulations. So people already started working it. Not only already started, I will say R&D work has been done. They are offering to the tire companies that is free from the RF free resorcinol formaldehyde. Here I would like to touch upon one point, Piram. This pink, the dip, which is that we call it the resorcinol formaldehyde dip. It is over 6 decades adhesive system for the textiles. No, practical things, practical solution, alternative could be evolved even after spending so much R&D into it. But today people have come. The color of that fabric is not pink; it is almost white. But that is still at the, I will say, advanced R&D level. All trials are going on. So this is again a feature. If tomorrow there is regulations comes in a very hard way, we have, with the tire company, have to comply with that. So we are also in the tire company doing into it. Then the one more point I talked about means sustainability slide, that material from biosource and recycling things. So polyester from recycled bottles, polyester bottle. So people already did lots of R&D and they have come out with the product of high tenacity HMLS grade. It's a huge challenge to make this kind of a super grade polyester from the bottle, but people have succeeded at the R&D level. So they are offering products to the tire companies to making into it. And all those companies invested a lot in R&D because they know they have to abide by the sustainability, regulations and things. And the last point, biosource. So here some work. For example, lyocell. It is that rayon family, but it is not the rayon. Rayon has one negative things with regard to its processing, and it's not an environmental free process, environmentally good process. So lyocell is an environmental friendly process, but giving almost similar kind of properties and things of rayon. So this is also going to come. That is the forecast is telling. And in polyester, one of the monomer is one is the acid, that terephthalic acid. The other one is monoethylene glycol, MEG. So people are here also doing a lot of R&D. At least one of the monomers, that is MEG, not from the petroleum based source but from the biosource. So through this thing, what I'm trying to emphasize here, lots of R&D is going on, lots of things has already happened and happening. So and you have got already a connectivity with those sustainability and this automotive EV, how it is. So that's what I just wanted to say with this 2-3 slides, bringing connectivity and to answer the futures sustainability and things. Thanks, Peter.
Excellent. I give a pretty good overview about what's happening. I think there's a lot happening on the polyester side, yeah, in terms of research wise. Yeah. Videsh, are you doing anything on the research side of the nylon aspects?
Yes, nylon is also going on, but it is in a preliminary stage. It is also going on. People are doing it in the Indian spinners are doing it. It's on the preliminary stage now. Actually, they're going on in this. And even for the dipping also, there is one more thing. The dipping also chemical dipping. This one, RF free is there. One more, and some more is coming with. We can use 50% of the dip solution. Some is going in initial stage. It is in the initial stage. There are so many work are going on in the development phase. Reduction of the carbon because of the sustainability on the sustainability front. So many research work is going on.
Very good. And this ready-to-use fabric, is it anybody using it in India? What's like?
Yes. Very much. It is very much. Even JK also doing for some special products. They are doing it, ready-to-use fabric. And one of the global leaders is in Europe. He is the actually. I can name it. That's not a problem. It's a Milliken who is who said to be the most innovative industrial textile manufacturer globally. So they have come up with a whole lot of innovative products and then come to the tire industry. Look at this is the they have lots of patents into it, on this. So this is one way of a new product you are making and going with a basket to the users. The other one is driven by the mega trends you have to do for the future.
And is the overall cost will decrease by using this ready-to-use fabric because you are eliminating a lot of processes and manpower.
Absolutely. Yes. That is the whole purpose.
Yeah.
Actually, Milliken is the oldest company in this line.
Right. Yeah.
That actually one point of that total monopoly for cheaper or industrial fabrics.
But what about this recycled PET bottles, polyester from in India? Anybody tried an experiment level at least? And I know that Michelin did a lot of work on that. So, any Indian companies are doing trying that.
Yes. Yeah.
Yes,
So again,
they are doing.
which one, Viresta, you are talking about it as a fiber manufacturers? Yeah. Okay.
Yes.
Please continue.
No.
Peram, just to brief upon, yes, from tire manufacturers perspective, and being an R&D, yes, I asked for samples. I got it also samples. In fact, at the R&D level, I'm doing testing of those things, and I got a first level. I can share with you also. It is looks good, but it is long way to go. Anything you do for tire, it takes long time until and unless you do the field test and things. Na? Whatever you do at the lab level, it will be finally void.
Right. Well, it's a really interesting discussion. We covered a lot of things. We started with the beginnings about the what is there, where it is, the reinforced material, what is the function of it. Then we look into the evolution of it. Then we get into the application and the selection into it, and also the Make in India project. Then we enter into the hybrid reinforcement. Then we get into future. What are the trends in future? Well, I think we covered pretty good in this discussion. I know definitely it is longer than expected, but
Yes.
we need to justify the title, right? We need to justify the title that what you want to cover in this. I think it looks like more than 2.5 hour session. It's a really nice discussion today. I'd like to you guys to give a final remarks to the audience, as well as some I don't want to call summarize, but give us a what we discussed. May I ask Barun first, please?
First, for this extended sessions, as you rightly said, it was so live and things. Still, we glued to the seat and continued. Of course, we find here quite a lot of audience are still there. So I must express my sincere thanks and gratitude to them also. And I hope from their presence, it indicates that they also found it interesting. So that way we feel also satisfied. So my sincere thanks to the audience. Also, I would like to thank my organizations to provide me support of doing some of the R&Ds which I actually shared with you today, and my fellow colleagues, my reinforcement group, my physical group, they also provided a lot of supports to have some of these things, materials, what I would able to do. So as a whole, I really express gratitude to all of them, and to you also, Peram, your platform. When request came, I thought, why not? I always believe it's always good to share. When you share, you learn something also. Today also I learned. So thanks, Peram, to you also.
Thank you very much, Dr. Varun. It's really good to have you. I think we took a lot of juice out of your brain today. Okay, thank you. Okay, may I ask Mr. Virish? Yeah, thanks.
Yeah, this really very lively program. Actually, this one. Thank you very much giving for this platform, and all the information, all different varieties of experience has compiled in one. This one, na? Tire manufacturing, about the quality of the fabric, everything is compiled. It's very easy for the newcomers, and the sharing is it's good thing. Thank you very much. Thank you very much for the same.
Yeah, thank you, Virish. Narapati sir, please.
Yeah, as Dr. Sami was mentioning, first of all, thanks to you, but more importantly, to the audience or to the spectators who has been like a glue. They have been watching it, and thanks a lot for your patience. And only, Bruno, I've got only one point. See, the other way of sustainability, the question is try to regenerate the components from the used tires. Though we know reclaim rubber is going on, but there is a huge problem that they say that look, even a problem like the collection of scrap tires. India is a vast country. Even probably till today, there has not been any rules, regulations, or control anywhere. Though reclaimed rubber is one of the most important, it will be one of the most important items. Even to regenerate the chemicals like carbon black separately, the reinforcing material, chemicals, how to regenerate it and reuse it. For sustainability, probably that's what the main program.
Absolutely. Absolutely right, Dharda. And to Peram, because that was not our subject to tell you, already technology developed and people have, getting carbon black out of the scrap tire,
Yes.
getting oil out of the scrap tires. So thing is that this sustainability, recovering those things is already there in a big way. That is a different world, a separate world for that. Yes, Dharda, you are very, very correct.
Yeah, we will be touching those subjects in the near future. There are a lot can be talked about. I still have one more question to you guys. I know we called abuse, right? Abuse of tires. I want to know which country really abuses it. Among which country ranks the number one in abusing the tires?
Okay, let me take. If you look at the kind of a load is happening, kind of road conditions are there. India is one of them, of course. There are Asian other countries, but with regard to overloading, with regard to road conditions, whatever you say, even after telling so much of regulations, they give some money to the check post and then go. Right, and on top of that, if something happens, that NSD little lower, they will come for the claim. Right, this tire got failed before that. So you have to really make your tire design not to satisfy the desired characteristics of loading, but you have to design your tire how it can sustain against the abuse. So this is the actually fact. I'm not telling what I mean to say. I'm telling not for all category of tires. Yes, there are super load, heavy load, and overload segments like that.
Yeah, Varun, I'd like to add up my experience. I was working in a tire company. One point of time, the very senior police officials came to the office, and practically they were accusing the tire company that when the Pune-Bombay highway started, there were a lot of accidents every day. It was miserable solution, and all are fatal. Then when they cool down, then somebody mentioned, just see, they are running at 100 kilometers per hour, 120. See the condition of the tire. Some are retreated tires, some are underinflated, and some are worn out. But how you can expect that in the highway at running at 120 that it will be a safe run? In fact, that was one of the eye opener. Even today, you are even the so-called educated or high-end people, whether when they have checked the air pressure, and even forget about it, you ask them that what is the brand of tire you are using. See how many people can answer to that.
It's a very good point he said. Mr. Peram, we all are using cars. We all are using. Do you know what kind of pressure you need to maintain it? How often you do check your air pressure? To have the tire performance life proper, you need to maintain the inflation pressure to the right level. So people's ignorance also you have to take in the tire design. So they are going to happen under inflation. So you have to take that also. So that's the unfortunate part of the tire manufacturers also. That's what I was telling in the beginning. Thanks.
I would like to add one more. Just a minute, just a minute. This one is last month only when we were traveling in the capital city of India, in the Delhi. I am with some tire manufacturer. We are traveling in that car only. Car got the tire gone flat actually. Then instantly the same tire manufacturer is sitting in that same car. It has gone flat. Then the driver came and he changed it within 15 minutes. Then he said the marking is there. You have to change. Why or not change? No, till it gone bad will not change. This is the concept of the drivers. This one, it was he shown the car manufacturer, tire manufacturer shown it. This is the marking. You have to change it. It will not change this one. It's mostly in
Yes.
Asian countries, not only in India. It is there in all the Asian countries.
Yeah, I think there is a lot of education required related to the tire safety, and the continuous efforts to be made, So, and also maybe that the tires retreating also will be challenging in particular summer countries because they get abused a lot. It's difficult to retreat them. Yeah. So, okay, guys, I think we need to end this session here. Sincerely, thanks to you all. I really enjoyed it. This whole session on the panel discussion on the present and the future trends of the textile reinforcement in tire and rubber industry. Once again, Dr. Barun, thank you very much. And Narapati sir, thank you very much. And Mr. Viresh, please, sincere thanks to you. It's really wonderful and sharing your experience. I'm sure that audience will be benefited from this the program. Okay. Okay, guys, that's the end of this program today, and you can find this session on YouTube channel and at TechnoBiz. I know this is pretty long. Actually, the long is better because we are covering extensive issues on specific topic, and we had Dr. Barun, Mr. Narapati there, and Mr. Viresh. They gave us very interesting, useful input in this subject today. I'm hoping that you really find it useful. And please check again. If you find it's too long for you, you can always go back to our on YouTube and find this session, view it again. Okay, that's the end of the session. If you need any assistance, if you have any comments, you know how to reach me. My name is Peram Prashadara. I believe everyone you have my contact information. One email, one message is a way to reach me out. Okay, I hope to see you in the next week, Rubber Industry News Hour. Thank you all. Bye bye for now.
Thank you.
Thank you.
Bye.
Thank you.
Very much.
Thank you, Mr. Param.
Okay, bye bye for now.
Bye bye. Bye bye.